Всем привет. Раз, проверяем звук вначале, да, как обычно все. Так, тут есть, а тут как обычно, долго. Ну, тут тоже все есть. Отлично. Замечательно, чудесно. Что ж, еще раз всем привет. Начинаем, продолжаем. Мы тут дофига всего сделали в прошлый раз. И дофига всего будем делать. Ну, мы прослушали в основном все там. И часть прослушали. То есть прошло мимо все. И часть что-то закрепилось. Вот. Пока запись надо начать. Вот начал запись. Все отлично. Так вот. Прослушали. Просмотрели. Что тут у нас было? С таймерами интересно. Там что-то как-то сет-таймер, да, было? Уже не помню. Ну, короче, то же самое по факту, что и у нас в блюпринтах. То есть такие же входящие параметры вот существуют. И там делает он то же самое. Вот. Следующий у нас тут видос. Можем приступить уже. Overlap Events. То есть это ивенты на пересечении, когда у нас идет. Давайте же узнаем. Так, звук надо включить.
So now we can walk around and we can shoot all we like. We have the basics of a twin six shooter, but these bullets are just going to fly through walls, and if we were to make enemies, they're just going to fly through enemies because we don't really have any programming to tell them what to do when they collide with something. They have a collision that's set to overlapping things, but they aren't being told what to do when that overlap actually happens. So let's take a look at that. On a normal blueprint, you might be used to having a begin overlap event. And that is very nice, and we're going to do something similar to that in C++. So what we're going to do here is I'm going to open up the base bullet class, because that's the thing that's going to be colliding or overlapping with all things. And I also have a other class open here because the overlap function that we're going to use does have quite a few parameters, and I don't want to mess them up. So I'm just going to copy over from my own game, where I have a class that also has a begin overlap function. It's very important that your overlap function has these exact parameters, because we're going to bind it to a delegate, which we'll explain more detail a little later, maybe. And when binding to certain delegates, you do need to make sure that the things you bind to it match it in terms of these parameters. Even if you don't plan on using all of them, you...
То есть мы объявляем begin overlap как обычную функцию, да? И задаем ей такие параметры, да, это uPrimitive компонент. Ссылка, да, это у нас, по-моему. Overlap компонент, потом actor, other actor, uPrimitive компонент, other comp. Все равно это не запомнится, так что идем дальше.
So what are all of these? Well, the primitive component is the overlapped component. So that is the components on this actor that's getting overlapped. Other actor is pretty self-explanatory. That's a pointer to the actor that you are overlapping with. The other component is the components on the other actor that you are overlapping with. The other body index I've never used, so frankly, I'm not entirely sure. And then we have a bool and a hit result for sweeping, and that has to do with... Sweeping is more or less checking one frame ahead whether or not something is going to collide, instead of checking whether or not it is colliding. So if this overlap happens as a result from a sweep and not from an actual direct collision, this will be true, and the hit results from that sweep will be stored in this variable or this parameter here. Now that we have that, let's make the definition for it, and we can start coding that in a moment. But this won't automatically do anything, because we're never running this, and it's not like just calling it begin overlap is going to run it when you overlap with something. It's not that smart. We're going to need to bind this to a delegate, as I alluded to before, and we'll do that at begin play. So how do we do that? Well, we already have a collision sphere, a sphere component here that is set to overlapping. So if we just get that collision sphere and we say on component begin overlap, we can add dynamic. And there we pass in a object, which is going to be this, and then we pass in the address of a function that matches this signature, which is the overlap component of the actor, of the component, and so on and so forth, the thing we just went over. And if you pass that in, now, whenever something overlaps...
Подожди. Так это он тут, получается, collision сфере обычной. Он говорит, что когда начинается overlap, он добавляет ей... функцию выполнить, типа, мол, которая находится в этом объекте и передает ей функцию begin overlap. То есть, получается, он сделал вот эту вот штуку. У нас есть сфера коллизии, да? Вот. Вот это вот она. Давайте сделаем немножко больше. Вот. Вот она, есть сфера наша. И вот что он сделал. Он по факту взял вот так вот. Шлеп. Не, подожди, это хит. Это не то. Это я обманываю. Begin overlap. Вот. То есть он запускает вот эту вот функцию. Мне интересно еще, как он получает вот эти вот параметры. То есть overlap компонент — это у него первый параметр идет, other actor вот второй, other comp потом, int 32 это body index вот этот вот. Ну, то есть он то же самое вот это вот получает, только у него там входной параметр этот идет. Как он его сейчас обрабатывать будет, давайте узнаем.
With this component, this function is going to run, and all of these parameters are going to get filled in with the relevant information. And that is, in a nutshell, also how delegates work. We'll get a bit more into delegates and making your own delegates and stuff like that in a future video pretty soon, because it's very useful stuff to actually use. Today, we're not going to play around with delegates too much. I do want to show you something that is almost equally as useful and is a little easier to understand and wrap your head around as a secondary objective in this video. Oh, and it is important to also mark whatever function you are binding there as a U function. Because when we overlap, what are we going to do? Well, first and foremost, we're going to destroy this. We're just going to destroy the thing itself. But we also want to do a number of different other things. And that is, we want to spawn a new particle system. And we want to, if it is a character that we are colliding with, we want to actually damage that character. Now, the damaging we're going to leave for the next time, because I want to really dive a little bit more into it, due to the fact that Unreal has a built-in damage system where you can send a deal damage to an actor, and then that actor will run its receive damage function, and then you put all that information in there as to how that damage should be calculated, rather than calculating that all over here and just subtracting a number on a different actor. It's a very good system. It's a little much to get into today as well. But maybe you want to have some bullets that do special stuff, right? Maybe you want to have some bullets that when they impact, they spawn 3 new bullets that fly off in random directions. Maybe you want to have a bullet that when it hits, it creates an area of effect damage thing. Whatever we want to make a function that we can put different kinds of things in depending on the kind of bullet that we're using. And that's what we're going to get into right now, because we're going to be talking about virtual override methods. You've seen me talk about this a little bit before and kind of dodge around it because I wanted to explain it in a more proper context, and that's what we're going to be doing here. So in our protected section, we're going to be making a new function here, which we will first mark as a virtual. That will be a void, and we'll say it's called bullet hits. And you do want to spell virtual correctly. So what does virtual mean? Virtual means that this function can be overwritten by child classes of this class. So let's use the tick function as an example, because this is a virtual function, meaning that if I make a child of my base bullet, which maybe again, we want to make an area of effect bullet. So we would make a child class of this one, and then I could override whatever is in this tick function. So in this case, the bullet hit function itself on this class is going to be entirely empty. But if I make a child class that does make use of it, I can override the bullet hit, and suddenly it will do whatever I put into that function, because this base bullet says, just run the bullet hit function, and whatever is in it, we're just going to run, and we can actually fill that in on a child-by-child basis, which is really, really powerful. The override keyword at the end here is just something for you as a programmer to keep track of. Hey, oh yeah, there's an override method. It's not actually needed. It's just something that checks, hey, this function, does that A, even exist on the parent class to begin with, and B, more importantly, is it virtual or not? Because if it's not marked as virtual, you can't override it. So let's make a definition for it, because you do need to do that. And then whenever we overlap with something, we're going to run the bullet hit function, which again, in this class itself is going to be entirely empty, but we can make child classes of this, which will still run this function, but if it's overridden, it will do something different, whatever we put into it. And in a function that is an override function, like we have seen before, you will see that it can start with this super tick in this case. And that is just saying the function that exists with this name and these parameters on the parent class, which there exists a tick function on the parent class of base bullet, because that's just actor, run that first and then run whatever code I put in here. Or you can also run it at the very end if you wanted to. If you don't put this super tick in there, like I don't have that in my own class because I don't have anything in the parent function, but say you do have some functionality in the parent function that you don't want to run in the child version, you simply just don't include the super here, and it won't run whatever is in the parent function. And as an example from my own game here, I'll show you a little bit of code. That's the class that I took the begin overlap from as well. But here I also have a virtual void method called special attack. And you will see that special attack in this class doesn't have anything in it. And that is for the base weapon class. So I just make a class for the base weapon. That's not actually going to get implemented into any blueprints, but then all my other weapons are children of that. So if I go into my sword class here, you can see it's a child of the weapon class, and it has a override for the special attack. And here, I actually do have a bunch of code. And this way, my character just has a reference to a weapon, and whenever I do the special attack, all the character needs to know is just tell my weapon to do the special attack, and then based on what weapon I am wielding at that given time, it will execute the corresponding code to that specific weapon. Now, let's also make a U property edit defaults only for a U Niagara system, which is distinctly different from a U Niagara component that we've used somewhere before here. Yeah, that's a component, which means that it's going to get built as a default subobject in the constructor, and is going to be a component on this actor. This is just a Niagara system pointer, which is going to point to a Niagara system that we can then spawn in as a separate actor through some different code. So this is not going to be a component on this actor at all. This is just something that can hold the type of emitter that we want to spawn in whenever we overlap with something, which will be an entirely different actor, which is important because when we overlap with something, very soon after that, we're going to destroy ourselves. So we spawn in a separate actor to do some particle stuff. And that's going to need to be forward declared, actually. And we'll call that impact particles. And we will need the include for Niagara system.h in our CPP file. And that's not the only include that we need, because we also need to include the Niagara function library, since we need to have a way to spawn in that system as a separate actor. So that is the include Niagara function library. And now in our begin overlap again, we will say U Niagara function library, and then we will spawn system at location. And for that, we will need our world context object, which is going to be this as always. Then the Niagara system, which will be our impact particles. Then we need the location, which is just going to be our get actor location, which is going to spawn it in at the exact same place that we are at right now. The rotation by default is set to F rotator 0 rotator. The scale is just going to be 1. Auto destroy is automatically true. Auto activate is automatically true. And that's really all we care about. So we don't even need to put in any of the other parameters, because a lot of these parameters have default values. And when they have default values, we can just skip them altogether, which is great. So right now we have on our begin overlap, we are spawning a system at our location. We run the bullet hit function, which isn't doing anything right now, but it will give us the ability to do things in the future, which is really nice. And then we destroy this object. That's my bad. You don't actually need to put in a thing to destroy in the parameters here, because it would just destroy whatever object this is being run on. So if we had a different object like other actor, if we wanted to destroy the other actor, we would do it like this instead. If you don't put anything into the parameters, it will just destroy itself anyway. So I made a little mistake, but I hope that that's not too confusing. And now in our simple bullet, we have the impact particle variable here. I just made a simple impact particle system, and let's see if it works. And this map might not be the best example here, because you do seem to need to have generate overlap events on the target on as well. Well, you know, that's not that big a deal, but you'll see I just enabled it for this pillar. This pillar, they just go straight through, and this pillar, they will explode up against. And it does seem like they are looping, actually. We don't want them to loop. That's an issue with the particle system itself. I've set it set to loop infinitely. It should only loop once. And there we go. We have shooting, and we can interact with things. That's all very, very cool. So that is how you set up basic collision related things in C++. Again, do be aware that in order for that to work, you do need to have set generate overlap events on whatever you are going to be overlapping with, it seems like, which is highly annoying, but it does make sense. Like this character has it set to on by default, so if we put in another one of these characters over here, we can shoot this, and that should do the trick. And of course, it doesn't have any AI because we didn't program any AI, but you can see this way we can shoot at the enemies. And you probably want to also, the walls of like your dungeon or whatever you're making, probably want to also set them to have overlap events enabled, because that way these bullets won't go through the wall. And the reason that is relevant is because these bullets, if I press F8, I will be able to highlight one of the bullets that just flew off into nothingness, is all the way over there, and that's not going to despawn.
Ну да, у тебя чувак будет лететь бесконечно.
These things just flying out into nothingness and taking up a whole bunch of your memory. So you don't want that. You do want them to kill themselves after a certain time. So if you just make sure that all the walls will generate overlap events, it will just kill itself when it runs into a wall. It's also not a bad idea to just put in a timer in the bullet itself to just say, after 30 seconds, just like despawn yourself, just kill yourself.
Там есть зачем. Просто в чем прикол? Он говорит о том, что, мол, вот у вас летит бесконечно, куча пуль будет, загружать вам комп будет, все дела. Типа, мол, прописывайте там таймер туда-сюда. Но на самом деле есть в класс defaults вот тут вот life, как она там называется, initial lifespan, вот. И если поставить сюда какое-то количество секунд, он удалит этот объект. То есть вот такая вот история. Окей. Нифига непонятно. Ну как нифига, 40% может быть впитано было. Так, apply and take damage. Да, у нас следующий идет видос. Apply and take damage. Давайте узнаем, как он там делает получение и нанесение урона. Так, и вот так. И погнали слушать.
A game in which you can shoot an enemy and it doesn't die isn't a particularly exciting game. So today, let's talk about setting up an HP value for enemies and ourselves, as a matter of fact, and also dealing with damage to that HP value. It's actually remarkably simple. Unreal has an entire build.
Вот это интересно сейчас. Как раз узнаем, как он между объектами будет общаться.
It's going to have some sort of damaging or HP value system. So let's dive right into the code. And for that, we're going to go into our base magic character, because both the enemy and the player will need to have this information. We're going to go back into our bullets here, and when we overlap with something, what we're going to do is we spawn that Niagara system, and we run the bullet hit function, which doesn't do anything for the time being. We need to make sure that we have the gameplay statics included here, because apply damage is a gameplay static function, so we'll include that. And as you probably should know by now, that's in Kismet gameplay statics. And from there we can use gameplay statics, and we can say apply damage. There's a couple different ones here actually that I probably should highlight. There's point damage, radial damage, just normal damage, radial damage with fall off. For right now, we're just going to go for apply damage, but these are different types of damage causing. So we can say point damage hurts the specified actor with the specified impact. What's more important here is things like radial damage or radial damage with fall. These are things you can use for AoE attacks. So if you have a grenade, instead of spawning in like a whole collision box when it explodes to calculate who is...
Эта же история есть и в блюпринтах, то есть apply, point damage, просто damage и вот эти вот все истории. Но я, если честно, вообще не понял, в чем его прикол. То есть зачем пользоваться этим всем. Damage. Тут слишком много информации он в себя впитывает. Вот. То есть в моем проекте, который вот я делаю на блюпринтах, там я опять же не знаю, правильно это или неправильно, но я создал свою функцию. Вот. Через интерфейс функцию, которая apply damage, она принимает только то, что мне надо. Ничего лишнего. Вот. И тут я не понимаю вообще, что и зачем вот эти вот функции встроенные. Да ладно.
Is inside this collision box and all that nonsense, you can just apply radial damage and you can give in a radius or a radius with a fall off, and the damage will be calculated for everything within that radius, and with if you use with fall off, it will also the closer you are to it, the more damage it will do. So that's actually very, very useful, very, very handy to have. Today we're just going to use the normal applied damage because that's all that we really need. And that's the first parameter. There is a damage actor, which is going to be the other actor which we are overlapping with.
Если я сейчас правильно понял, то, что он объяснял, ну, point это понятно, то есть это точечный, а radial это имеется в виду, то есть все получат урон, кто находится... ну да, там, кстати, ж массив, по-моему, на вход был, ну-ка. Apply radial damage, да? Ну да, вот. Ignore actor, damage course. Это который игнорится, смотри. То есть сюда засовывается массив, который игнорится, а все остальные получат урон. Do full damage. Ну, короче, мне эти функции что-то не нравятся, мне проще со своей поиграться. То есть там не будет ничего лишнего, и ты всегда можешь добавлять. Ну, это касается, конечно, блюпринтов. То есть ты всегда можешь добавить и убрать все, что тебе надо и не надо. Вот.
Then we need to put in a float for the base damage. For that, we're just going to make a U property float base damage. So every type of bullet we create can have a different amount of damage it can do. Then next we need to put in a controller for who the instigator is. But let's make a separate variable for that up here first, actually, to make it a little bit less messy. So a controller player C for player controller, I guess, will be equal to get instigator, and that will get us the pawn that instigated this thing. But of course we need a controller, so we'll get controller out of that. And you'll easily see after we make this into a pointer, this line of code now makes sense, and we can simply just use that variable in here instead of having an entire line in there, because it's just very messy.
Подожди, я что-то о своем задумался. Ну, давай отлистаем назад прям мощно так. Вот сюда, да? Примерно здесь мы. И этот обсуждать давайте заново.
Which is going to be the other actor which we are overlapping with. Then we need to put in a float for the base damage. For that, we're just going to make a U property float base damage. So every type of bullet we create can have a different amount of damage it can do. Then next we need to put in a controller for who the instigator is. But let's make a separate variable for that up here first, actually, to make it a little bit less messy. So a controller player C for player controller, I guess, will be equal to get instigator, and that will get us the pawn that instigated this thing. But of course we need a controller, so we'll get controller out of that. And you'll easily see, after we make this into a pointer, this line of code now.
Опять же, он сейчас вписывает входящие параметры в apply этот damage. Но не знаю, я бы как сделал. Я бы, наверное, создал бы пустой класс и сделал бы в нем вот эту вот функцию apply damage. То есть, если мы хотим использовать личный apply damage, ну, естественно, прописать в нем все, что он будет делать, то есть там принимает актера, который наносит урон, принимает актора, которому наносит урон, вот, и еще там всякие какие-нибудь штуки, да, вот, входящих параметров. И просто потом подключаешь его через include, делаешь и вызываешь свою функцию эту. Там хз.
Now makes sense, and we can simply just use that variable in here instead of having an entire line in there, because that's just very messy. The damage cursor will just be this, which is this bullet. And then finally we need to put in the damage type. So let's just make, for shits and giggles, a U property for the damage type. Just put it in there in case we want to use it at a later point. So that will be a U damage type. But actually, I think we need to make that a T subclass of U damage type, because the way you make new damage types is making a class that is a child of the damage type class, and that way you can also put code into it, I believe. I haven't really done too much with this myself, but it's fun to just play around with a little bit. So let's call this just damage type. And then when we put that in there, I think this should now be a valid function. And now this will use the gameplay statics apply damage to get the other actor and apply a base damage amount, which is a variable that we made, amount of damage to that actor, and it will pass through the controller that we have found as the instigator, the damaging actor, so the bullet that actually dealt the damage, as this very object with whatever damage type this bullet has on it. So with that, and then on our base magic character, we will just copying this from the Unreal documentation, use the take damage function here, and that will be an override function because we are overriding a pre-existing function that exists on any actor, really. And
отлично, взял с документацией что-то.
For the damage amount, it takes in a damage event, it takes in a controller for the instigator and a actor for the damage causer, and we'll just implement this right here. This returns a float, which will honestly not be that important, I think, but we'll just return our damage amount here. And in here we can just put in any code that we want. And what we're going to be doing with taking damage is we make an HP value, which I already did for you because it's really that easy. A U property just called HP. It's going to be a float, and it will be HP minus equals the damage amount. It's as easy as that. And then in there we'll also include, if the HP is less than or equal to 0, we will also destroy that actor. And now when we apply damage, we will just make this run its take damage function. Now that we have this take damage set up, we can compile this whole thing, which I've moved that to my other screen because it kept overlaying with things and it just looked very ugly, honestly. We can see if we shoot this twice, he dies because our damage, I think we're doing 30 damage or something. I think I hard-coded that in just for testing purposes. Probably shouldn't do that. Yeah, that definitely should just be our variable. But our damaging works. So we damage things, and when they have less than 0 HP, they just get destroyed. And you can add whatever code you want to that. You have a reference to the instigator, which is your player controller. So if your player controller has something like a score value on it, you can just cast that controller to your player controller and add your score value to that player controller. It's really as easy as that. And now you will note, since we're doing 20 damage again, it will take 3 hits for this dude to die. Apparently more than 3 hits. I don't know why that didn't hit him. It probably actually hit his weapon, and that didn't count because we're hitting a different actor. That's a thing that you should be aware of. If you have multiple different actors very close together, and the child actor component is a different actor, it is a component, but it's also a different actor. It can very much be the case that like your weapon will block an attack and that will prevent damage from being dealt, which can be annoying. Or it can be a game feature, right? It's not a bug, it's a feature. And that's the basics of the Unreal damage system. Again, you could just make something that whenever the bullet collides with it, it casts to our base magic character and just directly subtracts things from the HP or runs a function on that subtracts from the HP, but Unreal has a really robust built-in damage system, as you've been able to see. It's a little bit more bothersome to use than that way, but it's also a lot more flexible, and in most types of games that you're going to be making, you don't want to rebuild this entire stuff yourself, right? That's the reason we're using Unreal, for the most part, is it has a lot of pre-build.
Типа да, но типа нет. Ну вот он говорит о том, что вам не надо все заново делать самим. Тут есть все, но, блин, я с applied damage вообще не согласен.
By the way, that if you have your health or whatever, you want to have that code on a component rather than on the actor itself, there is a good way of doing that with this on-take any damage delegate as well. In this video, we've only done it directly on the actor, and you can just run the take damage function, and that is the easiest way to do it. If for whatever reason, like me, you have a component here in my own game, which holds all of the values for HP and that kind of stuff, what I do here, real quick, is on begin play, on that stat component, I get the owner, which is just the actor that this component is on, and then on take any damage, I bind with add dynamic again, this object, so this component, and then the take damage function for that, and that has a slightly different signature if we're using this method. So what we're doing there is we want to have the damage actor, a float for the damage, the U damage type, which has to be a const, then the controller, which is the instigator, and then the damage dealer as a damage causer. So it's slightly different, and this doesn't have to be called take damage either. This can be called whatever, because we're not overriding any functions, we're not adding any functionality to parent classes or anything. This is just a function that we bind to on-take any damage. So that is how I personally do it in my game. It's a little bit more of a roundabout way of doing it, but it is also a way that you can do it.
Окей. Так. Окей, узнали, что так можно. Хорошо. Пока два видео мимо. То есть такого, что можно прям поразбирать, подумать прям не над чем. Ну, вернее, как сказать, тут все полезное, то есть все полезное, но мимо меня проходит. Так, здесь у нас blueprint pure function, то есть он сейчас будет объяснять, походу, что такое pure function. Но это классно, конечно, у него последовательность, но да ладно. Давайте узнаем, что такое pure function, мы же не знаем. Сейчас узнаем.
Already made here. We can move around, we can shoot, but we don't have our walking animation yet, and that is because that's going to be a little bit more complex, because that walking animation is going to always be a forward walking animation, but when we're shooting, the walking animation is going to be influenced by the direction that we're shooting in and that we're walking in, and all that stuff together makes for a little bit more complex calculations, which we're going to do in C++, but we want to do all of those calculations in C++, and simply, when we're using those in Blueprint, we're going to use them in an animation blueprint. We want those just accessible through one simple node, so that we don't have to redo all those calculations every single time when we want to use them in our animation blueprints. So I have made an animation blueprint here real quick, where I just get the base player character, get its controller, make variables from that, get a velocity variable, which I don't think I actually need, and I also set up a simple blend space, which I will show you right here. Which will blend between walking forward, walking backwards, strafing left and strafing right, or the other way around. And that just has a forward speed input and a side speed input that we can use. So if we go into our animation graph, we'll see I also set that up here. We have that blend space with two variables going into it. We're going to need to set these two variables. Now, in the event graph, what we want is we want to make a new custom event real quick, and that will just be our set walk animation, something along those lines. And at the very end here, that's what we're going to call. And this entirely depends on whether or not we're shooting, what we're going to be doing with this. So we want to set this is shooting variable that I've already pre-made as well to be the is shooting from our base player character. So let's see, is shooting, that's not available to us because I haven't made it a U property yet. And that's where we're going to get into some interesting stuff in a moment. So let's go to our base magic character and look into or rather into the player controller, because that is where we have the isShooting variable. Maybe that should be on the character itself. We'll see whether or not we want to end up changing that or not. But we're going to make this a U property, which will be blueprint read only. We only ever want to read this. Let's compile that. And that makes a lot of sense as well, why we couldn't get it out of the character, because we need to get isShooting out of the controller. So now that we have that variable in our, I'll zoom in a little bit actually, in here, we're going to use that isShooting for a simple branch. If we are shooting, we're going to do some math, which again, we're going to do in C++ in a moment. If we are not shooting, what we want to do is we want to set our side-to-side movement to 0. And our forward movement is going to be our velocity. And we're going to get the length out of that. And for now, you will see that that means that as long as we are just walking around, we are always walking forward, and that works perfectly fine. The moment we start shooting, things break apart a little bit because we haven't programmed in what we're going to do there yet. So, of course, what we want to do is we're going to want to set the blend for the side and for the forward in that case too. But how are we going to get that information? We're going to get that through a blueprint pure node. And if you're thinking about blueprint pure nodes, what does that mean? If you are used to using things like get game mode, this is a blueprint pure node. It's a blueprint node that doesn't have an execution pin and is just a function that returns a value. Simple as that. You can make those yourself in C++ as well. So let's go back into Visual Studio Code here and make a function for that. So we want to make a function that returns 2 floats, and you can't really do that. Well, you can do that in a few ways. You can pass in a pointer to a float variable and change that in the function, but that's not really what we want to do with a blueprint pure node, because that then requires execution stuff. Instead, what we're going to do is we're just going to make something that returns an F vector, and we'll call that calculate movement blending. And that's going to be a U function, and the type will be blueprint pure. And let's make an implementation for that real quick and compile, just so that I can show you how it works in Engine. So now that we have that, we can use our controller variable that we've made. Remember, we made that right here after casting to it. And now we can simply get the calculate movement blending, which will simply return a vector here that we can split. And we're going to, when we make
опять
a function,
не там клацаю, подожди, опять за свое задумался. Что?
Blueprint pure node, because that then requires execution stuff. Instead, what we're going to do is we're
Вот CPC spec. NVIDIA 4060 Ti. AMD Ryzen 7. 3700, maybe. I don't remember. 64 gigabyte RAM. Something like that.
We're just going to make something that returns an F vector, and we'll call that calculate movement blending. And that's going to be a U function, and the type will be blueprint pure. And let's make an implementation for that real quick and compile, just so that I can show you how it works in Engine. So now that we have that, we can use our controller variable that we've made. Remember, we made that right here after casting to it. And now we can simply get the calculate movement blending, which will simply return a vector here that we can split. And we're going to, when we make the function in a moment, we're just going to set the X to being the side to side here and the Y to being the forward blending. And that way we can get these two values out of one blueprint pure node. So let's just plug those in already. So that's all set up. Now let's go back into C++ and start coding this thing. Importantly, in a previous video, we made a F rotator for the shooting rotation and an F rotator for the movement rotation, which gets set whenever we input anything to do with shooting or movement. So we're going to be using both of those rotators here today. And we're going to be making F vector for the movement, which will be equal to our movement rotation dot vector. That way it just gets converted into a normalized vector. I believe it's normalized anyway. And then we'll do the same thing with our...
Понятно, делаем вычисления, потом возвращаем их тут. Это понятно.
This way we can actually do vector math with it. The rotators themselves are a little bit weird. What we want to end up doing is we want to get a float here, and that float is going to be our dot product of those two vectors. If you don't know what a dot product is, the dot product of two vectors is a float that just more or less tells you how much of a difference there is between the two vector directions. And we can get that from the f vector static function called dot product, which takes in our two vectors here. So that will be our movement vector and our shooting vector. And now we have a float that has that dot product in it. And actually, that dot product is going to be our forward blending component here. So that's, I believe, the x component in the vector that we're going to eventually return. But we also need the side to side, and that needs a little bit more math to it. Just a little bit, not too much. What we want to do with that is we want to get our original shooting vector here, and we want to multiply that by our dot product. And then we want to get our movement vector here and put that in front and subtract the shooting multiplied by the dot product from that. And just for good measure, let's make that into a variable here of its own. So that will be our blend vector. It's not a very good name for it, but we're going to stick with it for now, because the length of this vector will be our side to side movement. So now we have everything we need. So let's just simply make a vector again here, and let's call that output vector, and that will be equal to a f vector, where the x component will be our dot product, the y component will be the length of our blend vector, so that blend vector dot length, and the z component will just be 0. And then that is the vector that we will be returning. And it seems like I mixed up the side to side and the forward blending, so I'm just going to switch those back around because it's easier than going back into C++ and changing things there. So in theory now, we can walk around and we can shoot, but we still are stuck in the idle animation. And that actually does make sense, believe it or not, because what we're returning here is a vector of a value that is somewhere in the range of like 110. That's not very, very much. So what we actually want to do here is we want to return our output vector.
Тоже сомнительная такая история. Ладно, помолчу.
Something like 100. That way, all of the components get increased to a size where we can actually reasonably work with them. You could also change the blend space around to blend between values of 1 and 1 rather than 100 and 100, which I did. I prefer doing it this way, but it's very much up to yourself. And now you can see we are moving in the direction that we are putting in, and the animation actually matches depending on what direction we are shooting in. No matter what direction we're shooting in and what direction we're moving in, our animations match up to those directions, which is very, very nice. Now, there's quite a bit of math here with doing the dot product and then multiplying and subtracting and adding and all that kind of stuff, which that might intimidate people a little bit, but really what's happening here isn't all that complicated. And if you just go through it a couple of times, you'll probably start to understand what this is all about. The main thing that I wanted to show off here today isn't all of this math, because math is boring, right? The main thing I wanted to show instead is the blueprint pure U functions, in which we can have one of these nodes that doesn't need to have an execution input and instead just calculate something to return a value for you to use. So if you just have a single variable that you want out of a C++ class, you can just make it a U property and blueprint read only or blueprint read write. But if you want to have something that needs to be calculated in a function in C++ and you just want a simple that is so for you to use. So if you just have a single variable that you want out of a C++ class, you can just make it a U property and blueprint read only or blueprint read write. But if you want to have something that needs to be calculated in a function in C++ and you just want a simple output, just something like what we did here today with calculating this, you can make it a blueprint pure node, and that way it just returns you your eventual output value without you having to set up a whole bunch of calculations in blueprint, because that's the whole reason we're using C++. So we don't need to do this.
Окей. Что-то чем дальше в лес, тем все веселее. Я пропускаю все мимо. Но Хоть что-то, да, и отложится. Надо все равно смотреть, пытаться и еще раз пытаться. Вот, а ну-ка, сейчас кое-что проверю. Давайте дальше смотреть. Значит, дальше у нас идет Refactor Your Code. Вот, такая вот тема. Давайте смотреть, что он нам хочет поведать.
We pretty much have a playable character now. We can walk around, we can shoot, and this is really what a twin-stick shooter is about. And that means that we are starting to edge up against something that might resemble the end of this C++ basic series. There's a lot of things to still talk about, so let's get started on making an enemy here, because we have a player, but what is a game where you shoot things without things to shoot? So let's make things to shoot. And for that, I'm going to admit something to you. We put a lot of code in our player controller here, and for the most part, that worked fine until now, because a lot of the code in this player controller we would have to duplicate in our enemy AI controller, because things like this shoot bullet kind of thing, this code probably should have been on the character itself, because both the player and the enemy are going to need to do this stuff. So let's take our base magic character here.
Как с child он будет, ну, типа parent child создавать, или он будет просто копировать?
And then, well, the bullet fires itself. And we just call that function here anyway. So what we will instead do is we'll change things around a little bit and prepare things for an AI to be able to use them as well. So what we'll do is, going back into the base magic character here, we're going to instead take in our shooting direction as a parameter here. And we're going to change the can fire variable also over to the character itself rather than the controller and all that stuff. I'm not going to bother you too much with that, but I will show you in the end. So I'm going to zoom out and I'm just going to quickly migrate all this code over to my base magic character. So first and foremost, let's just cut everything out of this function, and I'm going to just put all that on top of this function here. That's going to make this quite a big function, unnecessarily big, really. We're going to take this player character, shoot bullets, back into our controller. It's just going to always run this function, and then within this function, that's not ideal, but that's the way we're going to do it right now. Within this function, we're going to check whether or not we should be shooting in the first place. And take out that if statement as well. The direction that we're going to be using here will be a parameter for this function instead. So let's put that in the header file as well. We can cut out this line and also put that back into our controller. And we're going to put that before we actually call the function, because this vector is going to need to be the parameter for that shoot bullet function. And then we're going to need to copy over a couple of variables here, like the shooting rotation and the can fire, the time between fires. We're going to need to copy over a function, all that kind of stuff. I would like you to do that on your own. I'm not going to walk you through everything just moving over code. You can just move over everything like I just did and look through everything that throws errors at you and see, hey, what should I do with this? It should be pretty straightforward. One important note to make though is, if you're moving over your functions as well, you're going to need to change around the class that you have these functions defined in, of course, because they're now in a new class. Again, should be pretty straightforward, but something that I figured maybe I should actually point out. And then we take this out of the tick function of our controller, and finally we put that into this tick function instead. We can take out.
Ну, отлично, он просто в чарактеры переносит, из контроллера переносит в чарактеры, чтобы по ходу просто чайлда создать.
All of this code that we had on the controller before, we also need to change this, is now on our base magic character, meaning that both our player and our enemy characters are both going to be able to use all of this code much more easily than having to just duplicate everything around to a separate second class. We do have a couple of things to actually highlight here, and that is the things that are specifically related to inputs. Those we're not going to put on the base magic character, because the base of the magic character should be able to be used for both the player and the enemy version, and input is only relevant for the player version. So let's get the set shooting true and false functions also back on our controller. Quite bad form to have functions with the same name on two different classes, because that's going to get confusing. We're going to stick with it though, because why not? Let's put those back in there. But they're going to do something slightly different, because what we're going to do is we're going to first and foremost create the definitions for these two functions that we just recreated. And what we're going to do in these versions of the functions, I accidentally defined this one twice. We're going to make a base magic character pointer, which will be our character, and we'll set that to cast a base magic character, and what we will cast will be our pawn that we are possessing. If that ends up being a valid pointer, what we will do is we will use our character and we will make sure that in that base magic character the set shooting true and set shooting false are public function, and we'll just run these same named functions on that actual character. And we can simply copy this over.
Это здорово, он опять вот делает косты. Просто из блюпринтов знаю, что косты не очень хорошая история. Вот. И я думаю, в плюсах абсолютно та же самая штука. Хоть бы один показал, как пользоваться интерфейсами через через плюсы. Вот. А тут все время cast да cast, cast да cast.
Will be the fact that we are running the set shooting false function. This is not ideal, I'll be the first to admit, but this is the easiest way to just refactor our code as it is right now. Now,
Привет, Игорь.
The last thing that we need to do here is when we move, we want to set our movement rotation on our character, because we don't have that movement rotation variable on the controller anymore. And that will be done in a much similar way here. So what we'll end up doing is we'll do this, and then our movement rotation will set in here, and that will be on the character. And that's likely not going to be in the public section either, so let's check that out. Both the movement and the shooting rotation should probably be in the public section too. And now we have our controller all set up to drive all the code on our character that can now be reused by an AI controller as well as a player controller. So while we have been working in our player controller so far for just ease of being able to literally do anything, this is a more scalable way because our code is now going to be reused by our enemies as well. Now, there's a few things here in my animation blueprint that don't work anymore because we're trying to get variables out of the controller that it doesn't have. So we want to get our is shooting from our character rather than our controller here, which again also feels like it makes a lot more sense to me. And we probably want this whole...
Да, логично. Непонятно, почему он сразу не поставил его в контроллер. Зачем было делать... Ой, в персонажа.
In our last video, we're now going to... we have that calculate movement blending. We're going to just get that out of our character instead. The wonderful thing about that as well is we don't want to do that. Is that we can now reuse this, which way around was it again? I think blend forward was X and then the other one was Y. The wonderful thing about all that is that we can now reuse this animation blueprint for an enemy as well. Because the enemies are going to have the same mesh, just a different material to differentiate them as enemies.
Ну да.
Logic all exists on the character.
Тут с тобой полностью согласен. Тяжело, когда не понимаешь английский, но как-то надо справляться, надо учить и понимать. Вот. Блин, что ж все заходят с движка Unity? До какого уровня доучил Unity?
And our enemy is going to be based on that class. So we can reuse a lot of this code very, very easily now. And just to see if everything still works, we can still move around. Our blending for our animations still works decently well. The only thing that doesn't seem to be working quite as I would expect it to would be our spawning in of the bullets. So let's check that out. Let's take the code that we have here that actually spawns in the bullets and put that into the if statement itself. I don't think that's the issue, but we might as well. And we'll set this active rotation in both cases. So if we do fire something, we'll return here.
М4 жесткий сдох, не понял. Сейчас как-то вырвано из контекста.
And
В чем
if
ты?
we
Не
don't
понимаю.
fire something, we'll just set the actor's rotation, and we will return a null pointer, which is a dangerous game indeed. And that seems to have fixed the issue for reasons that I don't quite understand, but it did. So now we're back to where we were at the
Отлично, он,
start
короче,
of
что-то
this
исправил,
video. Sometimes it's important to just take a step back, look at your code, and
почему
think,
сам не понял,
moving
да?
forward, is this going to be the best way of having this code function? Is it going to be more in my way than it is worth me just not caring about, right? So if I didn't change this around in this video, there would be a large chance that it would end up costing me more time working around the stupidities that I have implemented so far than it would have to just sit down.
Ну, короче, он просто перенес эти самые и что-то там исправил. Вот что именно он исправил, я не понял.
Location and way of doing things. So now things are a lot
Не
more
будем разбираться.
usable, a lot more scalable, and is going to save me a bunch of time in the future. So it is worth
Разбираться. Так, давайте дальше посмотрим, что у нас тут идет. Так, into behavior trees. Да, следующий видос. Давайте перед тем, как начнем смотреть следующий видос, вот, мы так сегодня вообще закончить собираемся, да, то есть еще осталось этот, потом IUN добавляет, потом я не знаю, что это, потом делегаты, потом USTRUCT. Вот USTRUCT будет интересно. Это предпоследний видос и последний How to deal with Unreal Garbage Collection in C++. Вот, хорошо. Давайте сделаем перерыв, небольшой, минут 5, вот в среднем туда-сюда, так сказать, и продолжим. Окей? Так, продолжать. Ехали. Звук еще вам надо, да?
A little refactoring of the code so that we could start making AI characters with the code we have already written for our player character, just to be efficient about things, right? So that's what we're going to be doing here today. We're going to be making a separate blueprint for it. Theoretically speaking, that's not actually needed, but we're going to do that. So the way we will easily do that is we'll just duplicate the blueprint for the player, and we'll rename that to blueprint enemy instead. And when we open that up, and then we can go into its class defaults and we can change its parent class around. So we have the base player character for our player, but instead we're going to be using the base enemy character class that we have made. So far, both of those classes don't actually have any code specific to them. They're both just the base magic character class that we have made. And there's a good chance it's actually not going to end up having too much code in either of them, because the main difference between the two of them is going to come from their controllers. Our player controller, which we have made up in the last number of parts, and the AI controller and behavior tree that we're going to be making going forward. I do want to change the material. So now we have an enemy wizard. It's a wonderful material, by the way. Whoever made this, props to you. Now, selecting the topmost thing here for the BP enemy, we can go in and check its controller, and its default AI controller will be the just AI controller class. And we're going to make a specific class just for this. We're actually not going to, interestingly enough, put too much code in that, because the code that's going to drive the behavior for this character is going to come from its behavior tree more so than its actual controller directly. And you will see what that means in a second. We also want to see auto-possess for the player should be disabled, and auto-possess AI should be placed in the world or spawned in the world. So that way, whether or not we spawn something in through maybe a different enemy dying spawns this enemy, or whether we just place it in a world from its behavior tree more so than its actual controller directly. And you will see what that means in a second. We also want to see auto-possess for the player should be disabled, and auto-possess AI should be placed in the world or spawned in the world. So that way, whether or not we spawn something in through maybe...
Тут полезная штука. В проекте, который делал я, ну, делаю еще, да, пока, в блюпринтах, на каком-то стриме, там 15, 16, может быть 17, я хотел сделать спаун точки для мобов, вот, и он не хотел их спавнить. И вот, скорее всего, из-за вот этого вот он и не хотел спавнить, потому что placed in world только было. А нужен еще установить placed in world or spawned. Вот. То есть он, получается, запрещает спавнить этого. То есть ты можешь установить только... какие там варианты еще были? Ну, подожди. Ага, вот. Disable, то есть вообще выключить. Placed in world. Это только вытащить его в мир можно. Спаун это только заспавнить. И можно и то включить. Угу. Вот placed in world or spawned это прям полезная штука. Вот, хорошая информация. Я вот говорил, что нужно смотреть всегда. Из всего можно вытащить чего-нибудь полезное. Вот из всего, даже если что-то ты знаешь, вот смотришь какой-то гайд, потому что ты знаешь, и вроде даже чувак что-то делает неправильно, я, по-моему, рассказывал уже историю, вот. Да, я ее рассказал. И все равно вот будет какая-то мелочь, которую ты не знаешь, и будет она полезна. Вот.
That way, whether or not we spawn something in through maybe a different enemy dying spawns this enemy, or whether we just place it into the map, it will always get auto-possessed by the AI. So let's get to making a new C++ class here. We'll go all classes and we'll make an AI controller. We'll call this base enemy controller, which once again is not going to house too much code to begin with, but we'll figure it out. This is going to have a couple of variables though, and a begin play, which I'm just going to copy over from one of my other classes because it's always the same, and we'll create a definition for it. And as you might recall from earlier in the tutorial series, sometimes you get these weird little errors, which is reveal our U project in the Explorer and generate Visual Studio project files, and you just sometimes need to do that. It's annoying. Anyway, in our base enemy controller, in our begin play, what we're going to do is we're going to run a behavior tree, and that needs a U behavior tree pointer, and that's going to live on our base enemy character on the header file. So here we'll make a U property, edit defaults only, or edit anywhere. I'm going to go with edit defaults only for now, and that is going to be a U behavior tree pointer, which we'll call the BT asset, and you're going to likely need to forward declare this as a class. Going back into our controller here, we need a reference to that. So what we're going to do is we're going to first and foremost include our base enemy character. And we're going to try to make a base enemy character, which will be our enemy variable here. And as we're probably used to by now, we're going to try to cast that to a base enemy character. And the thing we're going to get cast here is going to be the pawn that we are possessing. If that is successful, then we will run the behavior tree. And the behavior tree that we will run will be the behavior tree that we just put onto that enemy. So BT asset. You also probably want to check whether that BT asset is valid as well in that if statement. It's inaccessible though, because I am an idiot and didn't make a public section here. And by default, everything is private. So let's make that public. And now we can compile that and we can start making our basic AI. I have a basic series on Blueprint AIs as well. And for the most part, it's not going to change too much for C++. So we're going to go through this relatively quickly, hopefully. Going back into our blueprint for our enemy, we can now see we have, if we delete the search, we have a BT asset slot. So let's make a behavior tree, shall we? We also probably need to start organizing things a little bit better, but I will do that some other time. If we go up into artificial intelligence, we can make a behavior tree, and let's call that BT basic enemy. And that will be the behavior tree that we use on this enemy. Behavior trees are
вот сюда я никогда не залазил. Тут сейчас интересно должно быть.
A character can follow based on certain conditions given. So we have the root. This is where the behavior tree will always start, and when a path is completed, it will reset to the root and choose a new path. And from there, we have selectors, we have sequences, and we have simple parallels. I do believe most of these will be relatively self-explanatory. The simple parallel is doing 2 tasks or 2 subtrees, really, potentially, in parallel. Honestly, I don't often use these. The sequence will do anything you put under it in a sequence, so it will do one task, and then the other, and then the other, and then the other. When a sequence is started, usually you don't break whatever it does the entire thing, and then it moves on, like resetting or whatever. And the most important one that we're going to be working with here is the selector, because the selector will select one of the things beneath it. Where the sequence just does everything that is linked up to it, under it, the selector will choose one of the things that it is hooked up to. So let's say we have 2 or 3 sequences. By default, what it will do is, and I will try to zoom in a little bit more, I can't zoom in more than this. Hopefully you'll be able to see that these things all have these little orbs with numbers on them. And this is the priority order. So coming from the root into the selector, that's 0. Well, then the selector will choose the thing with the lowest number priority. So it will choose 1, and if that's for whatever reason unavailable, it will choose 2, and then it will choose 3. This automatically just picks the leftmost thing. You can see if I choose this sequence to be put here, that becomes 1, and if I put that sequence all the way over there, this becomes 1. It just goes from left to right. So as it stands right now, whatever happens, it's always going to go root, selector, this sequence. Whatever we put into these 2 sequences is never going to get triggered. What we can do is we can add a decorator to it. So let's say we want to have a tag cooldown. This means that whenever this executes or fails to execute, whenever this is just selected, it will lock itself for, in this case, 5 seconds. We can also say 90 seconds, which means that the next time we're coming through here, it will check this, it sees, oh, it's still locked, and then sequence number 2 will be played instead. And there is a bunch of those selectors, as you could see. The most basic one is the blackboard selector, and that is because a behavior tree always requires a blackboard to be linked to it. And the blackboard is kind of like the header file for the behavior tree, where it houses all the variables that fit within whatever behavior tree we are building. So let's make one of those as well. We can right click on this. We can simply go into the artificial intelligence and make a blackboard as well. And usually just for organizational purposes, I like to just always make these in pairs. Sometimes you can reuse a blackboard for multiple different behavior trees. That's fine, that works. I like to just make them in pairs. It's a little bit less optimized, theoretically speaking, but in any practical terms, it's really not that big a deal. So with none of these nodes selected, if we go into our details panel here, behavior tree, we can set our blackboard assets to the blackboard we just made. And now this submenu over here opens up where we can put in our variables. And it also shows all the variables, or the keys as they're called, in a blackboard over here on the bottom right side. So if we go and add a decorator for a blackboard decorator to this sequence, we can now see we can choose a key to query. We can choose a blackboard key. In this case, that would be self-actor, but we can also make a bool like can shoot, just like any normal variable. And there we can say only if isShoot is set, which means that it would be set to being true, would we do whatever is in this sequence. Otherwise, it will move on to here. But what if we end up with a situation where can shoot is set to being false, and it moves on to this sequence, but while this sequence is executing, can shoot changes its value? Or the other way around, maybe we say can shoot is set to true, and while the sequence is being executed, it changes, and it should no longer be allowed to shoot. That is where we come into this notify observer, and the observer abort. By default, the abort is set to none, but we can also set it to only abort itself, so whenever the outcome of this bool changes, it will stop doing whatever it was doing in this branch of behavior tree. We can also say you shouldn't abort yourself, but when you see, hey, something else is happening in another side of the behavior tree and I am now suddenly able to do my thing, stop whatever those other branches were doing and do my branch. Or you can say both, which is cancel this branch when it's no longer allowed to be active, and also cancel other branches when I, again, am allowed to become active. That entirely becomes usually relevant when you add a very, very important node, which is the wait node. This just pauses the whole behavior tree for the amount of time you put in here. So you put in a wait time and a random deviation. So if I put in 5 and 1, it will wait 5 seconds plus or minus 1 second. So it will wait for 4 to 6 seconds. which is real nice. So that's basically how behavior trees work in general. Now, we have a lot of these tasks that we can do, right? There's a few that are pre-made here, like make noise, which is good for the perception system that Unreal gives you. You have move directly toward or move to. You can play an animation. You can play a sound. You can push a pawn action. You can rotate to face a blackboard entry. You can run behavior dynamic, run a query, set a cooldown tag. You can wait, or you can wait blackboard time. Those are all pre-made things that we're not all going to be looking into right now, but those are pre-made tasks. You can make your own tasks as well. If you come up here, you can make a new task, a new decorator. So you can also make your own decorators if you want to check whether or not something specific in your programming would allow or disallow a certain thing. You can make your own decorators that will allow or disallow branches of your tree to happen. And then we also have services. I want to talk about services a little bit before we start getting into making our behavior tree. Services you can put on any of these nodes as well. So we can add a service, and these have not that many default ones, but if we say default focus, we can set that. And the default focus is the thing that our enemy actor will be looking toward. That's just something that Unreal has pre-built for us, which is very nice. We can, of course, make a task for that. We can make a task to say, hey, default focus should be set to the player character. But things that need to run without being like the endpoint of your behavior tree, things that might also influence the status of some of these keys that can then influence how the behavior tree runs, all that kind of stuff. You can put those in the services, which means that whenever we go through this selector node, this service will also run. So whenever we go through the selector node, now our blackboard key for self actor will be set to the default focus. Now let's make an object here for our player instead. And then if you make a object key, that's kind of annoying. What you want to do is you want to open up this key type, and then the base class, we want to change that to actor in this case, because we specifically want it to look at an actor. It can't just look at any object. So we can set the default focus here now to the player, and anytime we go through this selector, the default focus will get set to the player. Meaning that if we, for whatever reason, anywhere else in the behavior tree, like in a node in here, set the focus to something else, whenever the tree resets, it will reset it back to the player, which is very nice. Other things that you can use this for is creating a node that sets a key on here, for instance, with the distance to the player. So you have a reference to the player, you have reference to the enemy itself, it calculates a distance and sets that to one of these keys. And then you can make a blackboard condition that instead of using...
Так, а дистанцию надо будет менять постоянно, если я все правильно понял.
Float distance to player. And you will see if we change the blackboard key from this bool that we've been using to a float, the queries also change. And now we can check whether or not this distance is equal to, or not equal to, or less than or equal to, or greater than or equal to. So let's say if our distance is less than a certain number, let's say 1,000, or actually let's say 1,500, that is when we want to shoot. I think we're going to leave it there for right now. This is the basics of how AI behavior trees work in Unreal. These are all the separate little bits of information that you need to know. If you are very...
Вот я, скорее всего, опять лезу впереди, да, но... А как он дистанцию будет получать? Ну хорошо, он ее написал. То, что он написал, это здорово. Ее-то надо менять, то есть ему нужно будет обратиться туда. Здесь мы же не можем... А, нет, подожди, мы можем, смотри. Вот, мы добавляем ее, то есть она как компонента идет у нас. Так, а ну-ка я вам вот так вот сделаю. Просто разобраться, да, то есть мы сюда ее подключаем, и потом отсюда мы можем вытащить, и вот здесь вот будем менять ее. Только есть проблема в том, что вот как раз таки вот эту вот историю нужно будет вешать на ивентик. потому что нам буквально каждый кадр нужно будет смотреть, сколько там, и передавать информацию, постоянно перезаписывать ее. То есть отсюда мы вытаскиваем нашу скорость, делаем ее сет и какую-нибудь там вот отсюда, допустим, нашу эту, точнее не скорость, а дистанцию. Дистанцию вытаскиваем и передаем постоянно. Вот. Окей. Хорошо. Правда, как пользоваться полноценно этим Behavior 3? Нам будет потом разобраться как-нибудь. Разобраться надо будет как-нибудь. Так. Дальше. Дальше. Тут такая чисто полезная инфа. Вот. Дальше у него идет как раз таки AI Decorators and Services. Так, здесь я скорость верну обратно на 1.2. Вот, ибо 22 минуты идет, потом еще 22, потом 18, 16 и 4. Так, и мы с этим мужчиной заканчиваем, и мы переходим к другому там мужчине. Там уже будет не на английском. Вот, и там видосы подлиннее и побольше их, по-моему. Ну ладно, это уже будет потом. Давайте с этим разберемся мужчиной. Так.
Actually make some artificial intelligence. We're going to make Skynet. Well, maybe not quite that much. We're going to make a simple enemy that's going to walk towards us, and within a certain range, it's going to shoot us. So we already made some things here in the previous video where I just gave a brief overview of the entirety of what behavior trees are like. So we have a couple of keys here for self actor, for can shoot, for player, and for the distance to the player. Today we're going to need to give this player a value. We're going to need to give an update, a value to the distance to the player, and we're going to need to make a task that will actually shoot a bullet when all those requirements are met. So first things first, we want to, whenever we go through this selector, we want to update the distance to the player. So let's go into our C++ classes here and make a new C++ class, and that is going to be a BT service. We're going to just use the normal BT service as a base here, and we'll call that one BTS update distance to player. I want to give the distance a capital D. And then we're going to create that class, which will create our header file and our CPP file, as we're used to. It's probably going to throw some errors at us because it just likes doing that. And here we're going to make a few variables. All of them are going to be U properties, and we'll mark those as edit anywhere. And the type of variable is going to be an F blackboard key selector. And we'll call the first one self actor key. And then I'm just going to copy over what I pre-prepared for you all. We also have one of those. You can give them a category if you want to. Why not? We'll have one of those for the player key and one for the distance to the player. Here we can select the blackboard keys that we'll have on our blackboard and say you're going to read the position for the actor itself from this one, you're going to read the position of the player from this one, and then you're going to write the distance between those to this one. And that we're going to do in a function, and it's important that this is exactly what I'm about to paste in here. So I'm going to copy it over from a different project. It's going to be a virtual void tick node with the parameters uBehaviorTree components, ownercomp, uint8 node memory, and float delta seconds. This is the same as any other tick function on any actor, except of course...
То есть он сейчас будет то же самое делать, только для, ну, как я говорил, через тик, он будет сейчас, короче, дистанцию высчитывать постоянно и записывать.
Actors, because they could be pawns, they could just be normal actors. By and large, they're probably going to be characters, but might as well just make them actors because there's no character specifically that we're going to need here. So we're going to cast that to a actor, and what we're going to cast is going to be our owner component dot get blackboard component. So that gets the blackboard component corresponding to this behavior tree. And from that, we're going to get the value from a key, and that's going to be the self actor key for our self actor, and that's going to be the player key for our player actor. And it's important that you get the selected key name because it's all based on the names. It's looking up names and comparing those to each other. That's a little annoying though, having to type out those names, which is why we have this variable type that can just give us a drop-down menu in the engine. We do have a little bit of a problem here though, and that is the pointer to incomplete class U Blackboard component, and that is because we don't have that included. So let's get this include added in there. We'll be able to fix that issue very easily like that. And then we're going to check if both of those values end up being valid. So if we just put actors into both of those keys, they should end up being valid. Then I'm just going to copy over this line of code here. We'll have a float for the distance, and we'll calculate that with the f-vector static function dist, and we'll get the self-actor, actor location, the player actor, actor location, and then in our owner comp, again, that's a parameter from the tickNode function, we'll get the Blackboard component, and instead of getting a value as object, like we did before, we will set a value as a float, and we'll set the value for the distance to player key, which is the key that we made here. And again, we have to use the selected key name and then put in whatever value it has to write to that key. Now, it's quite important to take a moment here and realize that because we're using all of this getting value as object and setting value as key, in the end, when we go back into the engine in a moment, we will be able to put in keys that don't match these types. We can put in any key we want into any of these key slots. Meaning that if we put a object or an actor into this distance to player, it's going to try to write a float value into something that cannot take in a float value, and that's going to cause problems. So you do need to be aware of what keys you put into what key selectors and how you use them. Now, just as a little bit of an extra little fun thing is we can make a constructor for this as well. And if we make a definition for that, we can give this node a specific name, because there's a variable called node name, and that takes in a simple string here, and we can just call this update distance to player. That way we can see the name of the node very easily when working with it in the behavior tree interface that we were just looking through. And that is it for the code for this service. So when we put this on any of the nodes in our behavior tree, when we go through that node, this will run, and it will update whatever keys we have put into it. Before you try to build anything to do with this though, this is a very important thing. You want to find your project name .build.cs. This is a C# file. And in here you will see we have a public dependency modules.addRange, new string array, and then it adds a bunch of modules. In that we're going to add in another module with the name gameplay tasks, exactly as it is right here. That will be needed if you are making BT services or BT tasks or decorators in C++. You'll be needing to add in that module. After you do that, you can build just like you can at any other time, and we'll remove this set default focus for now. And now we can add our new service, update distance to player. And when we select that, we get our self actor key, we get our player actor key, and our distance to player, which just happen to be set to the exact right things. But as you can see, I can put in any of the keys I want here. So do be careful about putting in the kind of key that you actually want to use there. Now, this
Это удобно, то есть ты типа, мол, от кого к кому дистанцию, типа, мол, указываешь сам сразу.
Is in the active path, but also it's not going to run it every single time, because a behavior tree, if it's just doing tasks and doesn't have any like wait nodes in it or whatever, can run a bunch of times, potentially tens to hundreds of times in a second. And you don't necessarily want to update all that information that often, because that's quite computing intensive. So what you can do is the interval between this running. So for the updating distance to the player, we actually want that to be run quite often. So let's run that every 0.05 seconds. So that will be 20 times a second. And we don't want any random deviation on that at all. So we're going to set that to 0. So now the self actor key will automatically be set to whatever actor the behavior tree is running on. The distance to player we are now writing to. The only thing we need to do is to make sure that the player actually has a value. And for that, we're going to go back to our base enemy controller. Just in the begin play function here, we're going to say that our enemy BT asset. For this, we will need to have a include for the Blackboard components. And the wonderful thing is, from an AI controller, you can just simply get the Blackboard components that this AI is using at the moment. And from there, we can set a value as objects. And the value that we're going to be setting, we need to pass in a name here. So do make sure that this is the exact spelling that you use. And then the value of that will be, we'll be using gameplay statics for that actually. So let's include Gizmod gameplay statics, and we will get the U gameplay statics function get player character. And then we'll use this as the context object. And then we need to put in a player index as well, which for now is just going to be 0. Now, I think it's a good time to test whether or not any of this actually works. So let's go into our BP enemy here and open the full blueprint just because I prefer this visualization, and see the AI controller for this class is going to be the base enemy controller that we've just made. And we should double check it has the BT basic enemy behavior tree. So in theory, when we place this into the world, which we have that one in the content folder, just place it into the world somewhere around here. I guess this one doesn't really need the camera now that I think about it, but we'll figure that out later. We can start the game and we can run towards it, and it doesn't do anything because it's literally just updating its own values. So let's actually open up the behavior tree here side by side with the gameplay. And this will be a little bit iffy because usually I do this on a second monitor. But we can see the self actor is BP enemy C, all this stuff. Can shoot is false because we haven't done anything with that yet. And the player is the BP player C0. So that is exactly correct. The distance is 325 units. And if we move around, we can see it is updating the distance very, very well. And now that we're standing right next to it, it's 68, almost nice. And when we run away from it, it increases. So, and you can even see if I show you right here. Right now, we're under 1,500 units away. 1,500 units might be quite a little bit too much. So it should execute whatever is in this sequence. But if I run away, you can see it adds in this little red block over here, meaning that it now notes that, hey, this is no longer a true statement. So this decorator is now going to return false, and this sequence is not going to run any longer. So now what do? If we are less than 1,500 units away, we want to shoot. That's fine. We'll make that in a moment. Otherwise, we're going to be moving to, and then we want to set that to player. So we'll just move towards the player until we're 1,500 units or less away. And then
мысль, не по теме. Смотрите, вот у него там обновляется таймер. Возникла мысль такая у меня. Так, сейчас я закрою, чтобы было видно. Немножко сменим, ну, почти сменим тему. Вот у нас есть какой-то кастомный ивент, да? Вот он что-то у нас делает. Таймер by event у нас есть, да? Вот мы подключаем, и вот он там ставил 0.2, да? Или 0.1 он ставил? Нет, 0.05, по-моему, да? Ну да, 20 раз, чтобы в секунду. Это вот так вот. То есть у нас запускается этот таймер, и вот он на лупе просто туда-сюда гоняет его. То есть он высчитывает нам дистанцию там, ну у него, высчитывает дистанцию. И что меня триггернуло на эту мысль? Вот у него 1500. Будет ли это целесообразно делать такую вещь? Блин, это дополнительную проверку делать, это нагрузить комп. Блин. То есть проверка будет постоянно выполняться. Блин, вот тут уже не знаю, есть ли смысл в этом или нет. Ну, то есть мы делаем вычисления, и дальше мы таймер у нас берется из какой-то переменной, да? Вот этот вот 0.05. И если дистанция больше, чем 1500, то мы берем и превращаем здесь его вот в такую вообще историю. То есть фигак, и в 4 раза его замедляем. То есть чтобы таймер не работал не так часто. А когда у нас, значит, дистанция опять снизится, там, или заранее, то есть сделать, если у него 1500, идет сделать там 1600, а 1600 она уменьшается. Вот, но на 1500 только триггерится, а вот этот бранч сработает только на 1600, допустим, да, там плюс 100. взять, сделать просто значение плюс 100, ну, которое нам надо. И вот здесь это уменьшить таймер, чтобы он меньше выполнялся. То есть, соответственно, все объекты, которые далеко будут. Просто в чем прикол? У вас на сцене будет 20, 30, 100 врагов, да, находиться. И вот каждый из них будет запускать вот эту вот всю историю. И он будет постоянно запускать таймер. Вот этот вот и ивент будет выполняться. То есть он будет высчитывать дистанцию и перезаписывать ее. После чего будет запускать вот этот вот root. Behavior root, или как там, как эта штука называется? Behavior 3, да? Вот. И там идти до вот этого вот момента 1500, да, проверки. И это будет делаться 20 раз в секунду. А сделав вот такую вот штуку, то есть взяв и уменьшив тайм здесь, точнее, наоборот, увеличив его, мы делаем, что он будет не 20, а 5 раз, то есть в 4 раза меньше. То есть тем самым мы экономим, получается, с одной стороны мы экономим, с другой стороны не особо мы экономим, потому что нам нужно будет делать дополнительные вычисления, проверять, больше оно, либо не больше, и делать бранч. Вот. Постоянно. То есть постоянно делать вот эту проверку, больше либо не больше. Вот. Конечно, было бы интересно узнать у людей, которые знают, имеет ли в этом смысл, то есть имеет вообще, нужно это или не нужно. Можно даже сделать 25 какой-нибудь, еще увеличить, то есть 4 раза, чтобы, а не 5 раз в секунду. Тем самым мы еще сэкономим. Вот. Ну, да, получается, общая, скорее всего, оптимизация будет проще ей. Просто одно дело, когда здесь будет висеть какой-нибудь там 1, да, там просто А-Б, да, и записать его. А другое дело, когда здесь что-нибудь побольше будет висеть. Да, и тогда такой бранч имеет смысл. Ну, в общем, вот такая вот мысль триггернула меня, когда вот он... когда вот он вот это вот делал, да? Давайте продолжим.
We change this back to 1000 and we'll copy over this decorator, yep, and say that only when we are within 3500 units, which is quite a lot, will we be moving towards our player. Otherwise, we will just stand still for the time being. You could make a little system here where it just like patrols around to a random location. We're not going to do that right now here today. What we're just going to do is we're going to have these things stand still until they're close enough to us, at which point they're going to come running towards us, and if they're close enough, they're going to start shooting. A little note here, I did put this on the sequence. You can just put these on the tasks themselves. If you just need it to be one task, you don't need to put like a sequence or a selector node in between. That's entirely unnecessary. And honestly, I just spent about 2 hours trying to fix an issue, and I think it's just a bug at this point, because I have my behavior tree here, and it doesn't work until I go into that enemy controller, and I change any random one of these options, like once player set. Has nothing to do with this entire behavior tree stuff, but when I change that, it then starts doing the behavior tree stuff, so I only have it chasing me around now. That seems like a bug to me, so I'm going to assume that you guys don't have that, because none of my other projects have that either.
Какие-то баги у него, видишь, не работает. Приходится рандомно эти менять. Ну, вообще, я не знаю, правильно, ну, как правильно, но есть такая штука, как AI. И я забыл, как она называется, да? Sensitive, по-моему. Pawn Sensing, да, вот она есть. И в ней есть вот эта вот штука, как on-see-pawn. Вот. Это когда вот в этот радиус кто-то попадет. Подожди, где он? Вот он. То есть, когда в этот радиус кто-то попадет, и радиус перед, то есть, если 90, то это в впереди только видно, да, получается, и 180 это если по... Ну вот, то есть 40 градусов, вот он видит только вот в этот collision попадает кто-то, если, то тогда он триггерится. Если не попадает, то нет. То вот так вот, по-моему, делают. Нет, они через behavior и distance. Ну да ладно, мы не о том сейчас. Мы просто смотрим, как он плюсы делает, а не о том, как правильно, как неправильно.
Let's make a new C++ class here, and this one will be coming from the BT task, so the BT task node. And this will say BTT for behavior tree task, enemy basic shoot. For this, we need to put in a function with this signature and this return type that I'm going to add in right here. So that will be a EBT node result type execute task behavior tree component node memory. That is the exact signature of what we're going to need. This function will run whenever our behavior tree gets to executing this specific node. So, of course, that's going to be quite relevant. And for this, we want to first get the controller that this behavior tree is running on. And from there, we can get the actual character that that controller is then linked to. So the way we do that is we make an AI controller, and we just get that from the ownercomp.getAIowner. That gets you an AI controller back. And from there, we want to include our base enemy character, because we're going to make a variable for that, which we'll call simply enemy, and that will be a cast, and we've done this about 1,000,000 times, so I'm not going to bore you through it too much. And what we're going to put in there is going to be our controller's pawn. So we do controller, and then we can get pawn, and for that we will likely need a include for the controller itself. So we include AI controller, so that we can actually use that line of code, which is kind of a requirement. And now we have a reference to a enemy character. From there, we can simply say our enemy, we want to shoot bullets. Now, we need a rotation or a direction for what direction we want to shoot in, of course. For now, since we will be most likely chasing the player anyway, the easiest way to do that is we'll just use the forward vector for our actor as it is, and that should just shoot in the direction that we're facing in anyway, and that should work decently well. So get forward vector. And this task, while being pretty rudimentary, should really do the trick. So let's compile that and see if it works. All the navigation related bugs aside, because of course, hopefully you guys won't have those issues. Basic enemy shoot is now a task that we can put in, so we can say that, and we can put our decorator on it for the blackboard, and say we want to shoot only when our distance to player is less than 1,000 is what we're going to go for at the moment. It's going to go through and update the distance to player. I just had a different service on that, if you noticed, that I made during debugging, which didn't end up being actually needed. It's going to update the distance to that player, and then if that's less than 1,000, it will shoot. If it's not, it will move towards the player. And let's change the observer abort for this one to lower priority. That way, when this one becomes true while we are chasing the player, we will start shooting instead, and we'll stop moving around. So now when we start playing, we should start seeing him shooting into a direction in front of him. Then when we are far enough away, we should see him stop doing that. And he doesn't do that anymore, indeed, and those are all the bullets. And then we have that bug where he doesn't try to chase us unless we go into his enemy controller, and we change something around here, and now he starts to chase us, and you can see he starts shooting at us as soon as he gets in range, and now we are dead. So we really should put in something with resetting the level when we die, but for now that will do. So maybe 1,000 units is actually a little bit too much, as well as let's go into the enemy here and change its time between shots to something a little bit more reasonable, like 1 second. And let's change this to like 750, so that it just has to be a little bit closer before it starts shooting at us. And once again, I really don't like this bug. If I figure out what that bug is, I will put it in the comments below or in a future video, but for the time being, there's not much I can do. And now we have an enemy AI that we can shoot at, we have to dodge them, and we can kill them. So that's the basic idea of coding an enemy AI. We have use the behavior tree now. We've made a service, we've made a task, a decorator works in much the same way. So for now, that's going to be it, and next time we'll do something else exciting. I'm going to spend another couple of hours trying to hunt down that bug. And maybe I'll figure it out, and there will be a transition explaining the issue. Some very, very good news. It turns out that actually I am just an idiot, and the reason that everything was going wrong is that in my enemy controller begin play, I forgot this little line of code. Super begin play. It wasn't running the begin play function on its parent class, which is the thing that enabled everything to work. So now you can see it'll try to move towards me and I can kill it, and definitely I do need to tweak some things like the camera on the player. Definitely needs to be a little bit further away. But that's a story for another day. I just wanted to finish this up by giving you guys the answer as to what my idiocy was. And on top of all that, something that I also should highlight is the player setup input components. I moved those to the actual player class rather than the base magic character class, as well as the whole set actor rotation from the movement and the shooting rotation. That also is now only on the player class rather than the base class, because the enemy is going to need separate logic for all that anyway. So that was also interfering with the rotation, and this just, I didn't need that on the other class, and it felt like it might be interfering, so I put it on the player.
Okay. Давайте сделаем небольшой перерыв, минут 5, по-быстренькому, и продолжим. У нас там дальше Decorators and Services, 22 минутки идет. Вот, и дальше уже получится видосы поменьше, да, по 18 минут. Так, давайте перерыв, 5 минут. Так, продолжаем.
Let's actually make some artificial intelligence. We're going to make Skynet. Well, maybe not quite that much. We're going to make a simple enemy that's going to walk towards us, and within a certain range, it's going to shoot us. So we already made...
Подожди, мы же только что это делали. Он 2 раза записал одно и то же видос, что ли? Подожди, в смысле? В смысле? Это тот же видос. Это тот же видос. Ну окей, 2 раза один и тот же видос записал под разными названиями. Ну бывает, бывает. Что ж это получается на один видос меньше, блин, это обидно. Так, у нас дальше делегаты. Я надеюсь, это будет сейчас познавательно, потому что пока процент... Ой, а этот остался, смотри, кота не убрали. Как так-то? Как-то да. Как-то печально сегодня идет все. Ну да ладно. Включаю вам и погнали следующий видос.
Halfway resembles a game. We've got an enemy that will shoot at us, it will look at us. I'll show you what I did to change that in a moment. And if we get too far, it will chase us down before it starts shooting at us again. So at this point, you can start designing levels and you're pretty much good to go as far as game development goes. But there's a couple of things that I still want to show you and that you should really know about. But first and foremost, the way I made this guy always look towards is very easy. Unreal has a built-in system for that. You can set an AI's focus and that will just rotate the pawn towards that focus unless it's doing something else that takes priority. So if it's standing still, it will always try to orientate itself towards its default focus, which I just set to the player every single time we go through this selector. It's a little bit of a overkill way of doing things, but if you were to set the focus do something else anywhere else in the behavior tree, it will always reset back to the player on the next loop. So today what we're going to do is we're going to talk a little bit about delegates, because that's one of the more important things that I haven't really covered yet. And what is a delegate? Well, a delegate is, if you're used to working with Blueprint, it is the C++ version of a event dispatcher. It is more or less, and I'm going to go into a blueprint here, things like the onDestroyed. This one, event destroyed, is an event that fires based on a delegate. Whenever we use the destroy actor node, that fires off a delegate that then fires off this event. So if we, for instance, say on begin play, we destroy the actor, and then on destroyed, we print a string, right? That means that immediately when the game starts, this actor is going to get destroyed, and as a result, it's going to print out a string saying hello. And we can see that is the case. So this is not directly hooked up to this, but still, it's running that way. And that's the way it works in Blueprint, but we can also do that in C++. And there's a bunch of pre-existing events in Blueprint that you can use, like event possessed. That's also a delegate which fires whenever a controller possesses a pawn, and so on and so forth. So let's make a delegate, and for now, because Unreal itself has so many pre-existing useful ones like onDestroyed, that is what I would usually use as an example, but that already exists. So we're going to make a delegate that fires whenever a bullet is shot from any character, really. And then we're going to, on one of the characters, subscribe to a delegate and do something with it. Right, so let's go into our base magic character header file, and the declaration of a delegate we actually do outside of the class. And I'm going to copy and paste the declaration here because this is kind of annoying to type otherwise. So what you want to type is declare dynamic multicast delegate, and then you can also put in a number of parameters. So you can make a delegate which fires a function with a specific amount and a specific type of parameter. So let's make one with one param. And then in these parentheses, we first put in the delegate name, which has to start with a F. So we say F on bullet fired delegate, something like that. And then we can put in the type of parameter that we want. So we want to know what actor fired this bullet. Maybe that will be useful information for us to have. So we can say a actor pointer. And then we do something a little weird, because then we put in another comma, and then we put in the name of that parameter. So unlike what you're used to in these functions that we have been using so far, where we have a function and there we do a type, a name, then a comma, then the next type, the next name, then a comma, next type and name, comma, next type and name. In making a type of delegate, you actually separate everything with a comma. So I also made a little typo here. Let's call that fired actor, and of course end that with a semicolon. If you want to expose this delegate type to Blueprint for any reason, you can make it a U delegate, and the specifiers that you can put in here are the same ones that you can put into a U function. So that's, I've got a page open here, Blueprint authority, Blueprint callable, Blueprint cosmetic, Blueprint implementable event, and so on and so forth. That's not what we're going to do here right now today, but you can do that if you would like to. And you might see some squiggly lines under this as an error, but you can see I can still compile this and this works fine. After a minute it catches up, and now we have this delegate to work with. So let's add one. I'm going to add this into the public section, because that way other actors will be able to access this delegate and say, hey, I want to know about when this delegate fires. So we're going to put this in the public section, and we can just use this as a variable type now, and we can make multiple instances of it. So we can say on fired bullet delegate fired bullets. But if we wanted to, we could also make a second one and say this one is called bullet fired or something like that. And we could run this one in some situations and then this one in other situations. We're not going to do that, but you could, for instance, if you go into the CPP file here, in our shoot bullet function, we have two different paths here, right? So if we can fire, we execute all this, and then when we return, this last line here doesn't get executed. So we could have one of those delegates firing in here and saying, hey, I'm calling out, which means that whatever is listening knows that a bullet has just been fired. And we could put another one in here, which would mean, hey, anybody listening out, a bullet was just tried to be fired, but it didn't. If that's for any reason, for anybody, interesting information, there you go. I don't see a reason to do that, so we're not going to do that. But that's just an example of you can use this just as a variable type, and you can have as many of these as you want. We're going to use this fire bullet though, and we're going to put that into our shoot bullet, and we're just going to put that into the if can fire is true. So at the very end here, we're going to say our delegate fired bullet dot broadcast, not broadcast. That would be quite nice as well. And that needs a parameter because that's how we defined it, an actor parameter. So we're going to just say this because this class is an actor, so it can just pass itself through to that parameter. That means that this delegate is now anytime we're going to fire a bullet as the player, as an enemy, because this is the base magic character, anytime anything fires a bullet, it's going to just scream into the void, hey, I just fired a bullet. Any other actor that might be listening out for that, which we're going to get to in 1 second, can then say, hey, when you fire a bullet, I need to do a thing, whatever that thing might be. And I can use whatever parameter is getting passed through here, so whatever character or whatever actor is firing that bullet, I have a reference to it now through this delegate, which is quite nice. Now, what can we do with this? Well, let's make something silly, something that we're not actually going to be using. But let's make something that increases in size every time the enemy fires a bullet. That seems pretty neat, right? That seems pretty cool. It seems real weird to me, is what it seems like. So let's make a new C++ class. It's just going to be a normal actor. It'll be private, and we'll say base weird growing thing. Do we need that name to be so long? No, and as a matter of fact, it's actually quite bad that it's so long, because now every time we need to reference this, we're going to need to type out that entire thing. And at this point, we're used to it. When we make a new class, for whatever reason, we need to go into our U project and generate studio files. And here we can make a new function. Let's put that under protected here. And we'll call that simply void grow, and it will be a very simple function. Because all it's going to do is we're going to set actor scale 3D, and we're going to set that to the get actor scale 3D multiplied by 1.1f. So it's going to grow 10% every single time. Well, actually, maybe we don't want to multiply. Maybe we just want to add to it. So we will say plus 0.1. And the wonderful thing about this, by the way, is if you add a float to a vector like this, it will just add it to all three components. So now we're going to add 10% of its base scale every single time this grow function fires. But how are we going to link this up to a specific enemy? Because that's the thing. We want to link this up to a specific instance of the enemy. Or the player, for that matter. We could also link it up to a player. Well, first things first, in order to access all that, we're going to need to include the base magic character. And we're going to need a variable for that as well. So let's make a protected U property, which we can edit anywhere. And that will be a base magic character pointer. And I do need to spell that correctly. And let's call this character to watch. And we'll likely need to forward declare this. So now we have a pointer to a base magic character. This can be an enemy, this can be a player, whatever. And we can say in our begin play, using that, we can now access our, what do we call it? Fired bullet delegate. And from here, we can say we want to add. What we want to do actually is we want to add dynamic, and there we just have to pass in, does it tell us, a user object, so the object that the function that we're going to run exists on. So in theory, what we could also do is we could have one actor saying, hey, whenever this character does something, this other actor has to run a certain function. It doesn't need to necessarily be something that they do themselves. You can have a manager object that just listens out for specific pairs of actors. When one does something, the other one will do something as well. That could save you having to include certain header files in other header files if you want to prevent that. That's a possibility. For the most part, you would just run a function on the object that this exists on. And then we need it says the function name, but what you do need to put in there is the address of that function. This function actually will not be accepted. And I'm going to pretend like that was intentional, because I entirely didn't think about that. The only thing that you can put in here, the only functions that you can put in here are functions that match the signature of the delegate. So let's go back real quick to our base magic character header file. That's somewhere in here, surely. There we go. We make this delegate to take in an actor pointer. And when we broadcast it, it passes through a pointer to itself as that parameter. So now when we bind a function to this delegate, it needs to be able to take in that actor pointer. Even if we're not going to use it, the signature does need to have that parameter. So let's go back to our other header file somewhere around here. add into our grow function just an A actor pointer, and we'll call that enemy watched. Something like that. It doesn't matter what you call it. One important note though is that the function that you're going to execute through being linked to a delegate needs to be a U function. You don't need to put any specifiers in there, but it needs to be a U function, otherwise it'll just straight up not do anything. And put that in there as well. That will solve all the issues. It'll take a minute for this to disappear, but now all the errors are gone. So we can compile this and now go into the editor. We will add some meshes, but we'll do that through Blueprint because we don't need to have all that accessible through C++. So let's make a quick blueprint here and still ignore the fact that this is all very unorganized. And let's look for our weird growing thing class, which is a great name. And let's call that BP growing. We'll simply add a cube. I think that will do just fine. And in our top-down map, we'll put in this BP growing cube here. And we'll say the character that we need to watch will be our BP enemy. You note that it only has things that are children of the base magic character. So if we put in the player character, for instance, it will also give us this as an option in the drop-down menu now. While there's a bunch of other different actors there as well. I'm going to actually put you up a little higher, and you're going to watch this enemy. So now anytime this enemy will shoot, this thing is going to grow. And this enemy shoots quite quickly. So this thing is going to grow way out of proportion way too quickly. Let's take a look. So now we can see whenever...
Привет. Было бы круто, если бы ты переводил параллельно, что он говорит. Привет, если я буду... Это невозможно. Это невозможно. Потому что, чтобы переводить, это нужно гораздо лучше знать английский, чем мой. Это, короче, если вот у него видео идет 18 минут, с моим переводом мы его будем смотреть час. Так дело не пойдет. Ну, на данный момент он прописал код, что когда стреляет враг, то на 10% вырастает в размерах куб. Вот. И это сделано с помощью делегатов. Вот. Потому что в этом ценность, так как в инете очень мало переводов англоязычных курсов. Но, да, но блин, но... ну хорошо. Параллельно переводить это невозможно. Это не мой уровень. Тут без вариантов. Что-то конкретное, то, что вот интересно, да, то, что я понял и хочу сам разобраться, то я останавливаю обычно, да, и там начинаю, размышлять о том, что было сказано, думать и так далее, вот. О том, что параллельно это не... Вот, а так можно задавать всегда вопросы в чате и, потом, вот что он тут сказал, о чем он тут говорил, я могу перевести там, да, из того, что я понял, вот. Вот так вот это может существовать, то есть задавать вопрос, а что бы тут было сказано, о чем тут идет речь, и вероятнее всего я скажу, что я сам ничего не понял, и как бы вот так вот. Короче, да, продолжаем.
That cube is growing. And the reason this is very, very nice is because it eliminates having to have a two-way communication.
Ты хорошо знаешь английский, но в плане понимания на слух нормально. То есть, как сказать, 80% всегда я понимаю. То есть, там вот то, что он говорит, то, что в других гайдах мы смотрели, фильмы всякие, там сериалы и прочее. Там видео обычные на ютубе, другие там 80% понимаю, остальное либо по контексту как-то оно само доходит, либо просто игнорируешь, это что-то неважное такое. Вот. Но переводить это прям идеально надо знать язык, то есть, это забей. Привет, очень благодарен тебе за твою работу, ты мне очень помог. Пожалуйста, обращайся. А с чем именно? Если не секрет. Что именно помог? Понял, хорошо. Да вот, так вот, да.
communication. I'm going to stop before that thing grows way too big. So this cube knows about this character, and it has an include to that class, which it needs to have in order to subscribe to that delegate. But this character doesn't necessarily need to tell.
Так, да, ты очень круто делаешь, что изучаешь вместе, такого контента нет. Но я рад, что я врываюсь в такую нишу, в которой нет конкурентов. Вот. Хорошо.
This cube to do anything, and as such it doesn't need to know that that cube exists, and it doesn't need to know all of the variables and all of the functions on this cube. And you can definitely like imagine a situation wherein maybe 10 different classes all need to do something when a certain character does a certain thing, right? Maybe
здесь он объясняет, что такое делегаты, и вот что он может отслеживать и делать что-то.
Right? A door needs to open, and barrels need to explode, and money needs to drop, and whatever. All those things can just look out for that character without that character needing to say, hey, you do this, you do this, you do this, you do this, and as a result need includes to all.
Опять же, для меня вот наличие интерфейсов говорит... Так, а ну не тараторь вместе со мной. Для меня вот наличие интерфейсов убивает вообще все. Косты, делегаты, диспатчеры и все остальное вообще полностью. Хотя делегаты немножко не то, но тем не менее. Вот для отслеживания. Сейчас фигню походу сказал. Ну да ладно.
Include on top of a class pretty much just copy paste the entire header file into that CPP file, meaning that it now has that entire class accessible. And if that's a class that's multiple megabytes big, every instance of that is going to take up unnecessary amounts of memory, which we don't want. So this is a good way to limit the amount of includes that you need. This way, it's just a one-straight communication. This block needs to know about this character, but this character doesn't need to know shit about this block, so we don't tell it anything about that. And just to make things complete, we can go back into our base magic class header file, and this delegate can also be a U property, and we can mark this as being blueprint assignable. And now we can go into our blueprint, and we can
из контекста выпало. Это для вариации сделали, походу. Похоже. Ну, да. Да. Но опять же, я не понимаю, если сделали для вариации. Ну, короче, для меня наличие интерфейсов убивает вообще вот эти все остальные штуки. Для меня они перестают существовать, в принципе. Вот. Ну, каст там, за исключением в некоторых моментах, он нужен. То есть ты не можешь через интерфейс делать там в некоторых моментах. Вот. А все остальное полностью убивается. Ну, хотя в понимании AI Decorators Petitask. Вот тут я вообще выпал из контекста, не понял, о чем речь.
Assign blueprint events to this as well. So if you, for any reason, want to do something in blueprints when a certain thing happens in C++, that's a good way to link those together as well. And now they just function as an event dispatcher. So we can say assign fired bullet, and there we just get an event which has the fired actor variable or parameter that we talked about before, and now whenever we fire a bullet we can do whatever this custom event says. And of course we can also do that from a different actor here, a different blueprint. So we can say begin play, we can cast to base magic character because we can assign fire bullet, and now we have an event on a different blueprint that will fire whenever a bullet is fired. So that's also a good way of getting information from C++ to blueprint sometimes. Between this video and the next one, I would like you to make a door bullet is fired. So that's also a good way of getting information from C++ to blueprint sometimes. Between this video and the next one, I would like...
То есть, я, мне кажется, начинаю понимать, косты наши все, фу-фу-фу, не надо туда лезть. Косты это зло. Тут он интересную вещь сказал, что, мол, вот этот вот... Слушай, вот эта вот фраза, в конце которой он ляпнул, она немножко начинает, весь видос начинает обретать смысл. То есть, он говорит, что это хороший способ для того, чтобы обращаться между блюпринтами, общаться и C++. Я сейчас начинаю думать, как это использовать. Ну, то есть, в каких вариантах. То есть ты свой этот создаешь, он делает перед, а потом после ты его биндишь. и ты его вызываешь. Ну, кстати, а почему обычный тогда кастомный этот не создать и не вызывать его через интерфейс? Косты можно в плюсах делать вроде. Вот не знаю, вот косты, вот этот мужчина в косты фигачит в плюсах только в путь. То есть, ну, прям в блюпринтах, допустим, я прям жесткий противник костов. Потому что, ну, оптимизация передает привет. А если в плюсах работает по тому же принципу косты, то это тоже не очень хорошо. Это прям вообще не очень хорошо. Вот. Поэтому фиг его знает. Если есть интерфейсы, то почему не пользоваться интерфейсами? Это настолько универсальная классная штука, которая позволяет общаться между объектами. Это просто забей. Ну, прям все с ней можно сделать. И геттеры, и сеттеры с ней можно делать, и все подряд. В плюсах все норм с костами. Точно? Не обманываешь? Ладно, я поверю. Так, давайте дальше. Там еще, по-моему, 2 видоса осталось. Ну-ка, сейчас я гляну. Да, 2 видоса осталось, 16,4 минуты. Значит, USTRUCT. Вот USTRUCT мы в предыдущем раз с предыдущим мужчиной что-то там, он USTRUCT как-то объяснял, нифига было непонятно. Надеюсь, сейчас что-нибудь полезное узнаем. Вот. Кстати говоря, следующий мужчина, то есть получается следующий стрим, когда он будет, не знаю. Вот. Следующий стрим по плюсам, вот так вот скажу. Там будет русскоязычный уже стрим. Вот. Так что там переводить не надо будет. Вот. Там мужчинка есть. Один мужчина. Вот, мы его будем слушать. Вот. Там видосов побольше, они подлиннее. И вот так вот. Так. Давайте USTRUCT узнаем, что такое. Точнее, мы уже знаем, что такое USTRUCT. Мы сейчас вспомним, или может быть дополнительно что-то новое узнаем.
Delegates, and I challenge you guys to make a door that would keep track of 2 specific enemies, and once those 2 enemies had been defeated, the door would open. And that is exactly what I've made off screen right here, and I'm very bad at gaming. So both enemies have been defeated, now the door is open, and we can go on to whatever would be in this next room over here. I also made a little bit of a more twin-stick shooter-like level design to go with that. And with that, I do think that we're getting pretty close to the end of the C++ specific course. There's a bunch of stuff that we can talk about, like adding widgets, adding UI, but most of that, while parts of it are possible to do in C++ if you want to, I personally very much like doing those kind of things in blueprints, using functions on the actors that exist in C++. So today I want to talk a little bit more about our health, because at the moment, if we go into our player blueprint here and we search for our HP, we find we have a single float with HP, and that's fine, but we're going to want to have a bit more in terms of stats. And we could just make a bunch of floats, and that would more or less work, but what we could also do is we could make a specific struct, a structure that holds a number of different types of variables that we can just look at as a whole, rather than every time we need to look at this.
Я буду пробовать сейчас объяснять, что он делает. Вот он говорит о том, что вот у нас есть ХП, и вот в идеале его хранить в структуре, чтобы в этой структуре, то есть будет одна переменная, и в ней будет храниться ХП и МП, допустим, и все остальное. Но в принципе в том проекте, который я делаю, в блюпринтах это все есть. То есть, если вам интересно, как именно это, что именно по блюпринтам, в общем, он сейчас будет создавать структуру и запихивать туда вот это вот все, вот эти вот ХП и прочие статы.
stats, we need to look at one float and then the next and then the next and then the next. We can just get that struct, and that has all the information we need in it, which is much easier, especially if we're going to be displaying those things, again, in widgets. We're going to set this up in C++, but then we would use this kind of stuff most likely in Blueprint as well. So let's get into that and into our base magic character header file. Just like we declared that delegate last time, outside of the class, we're going to do the same thing here. And we're going to be declaring a USTRUCT, in which we can also specify that this has to be a Blueprint type. That way we can also access this through Blueprint, which is quite nice. From there, we can just make a struct by saying struct.
Подожди, а как мы делали тогда? А вопрос, правда, где мы это делали? Класс. Где мы структуру объявляли? Подожди. Гейт, по-моему, да? А, да, вот гейт. То есть ее можно и там вот таким вот образом, да, то есть сделать.
And then this is kind of like a class. So we need to put in this generated body stuff here. And there we can just put in a bunch of variables. So we can make a public section and make a uProperty blueprint. Let's say read only for the time being, because we're only going to want to read from
Не
this.
понял, а что за generated? А, ну да, у нас тоже есть.
Edit defaults only, because we're going to be able to edit the health and the shot speed and the shot rate and all that kind of stuff on a per blueprint basis this way. And there we can just start adding things like the float for the HP. And from there we can simply copy paste a couple of these, and we can say our shot speed, our fire rate, maybe something like our movement speed. And then at the very end, the bottom here, after the closing squirrely brackets, we do need a semicolon as well.
И вот тут я хочу уже потестить самостоятельно. У нас есть наш ConActor CPP. Вот. И вот здесь у нас в какой там категории все это сделано. ConActor, да? Вот. ConActor. ConActor, вот здесь его все параметры, да, которые мы прописывали в плюсах. Молодец я. Молодец. Вот. Вот тут вот. Все, значит, параметры. Давайте попробуем сейчас. Я хочу сделать USTRUCT, вот этот вот. Объявить его в плюсах. Хочу, очень сильно хочу. Смотри, здесь и класс он объявляет, да? То есть как этот. Посмотри, в Tools там есть Blueprint C++ Header Viewer. Можно спокойно изучать и переносить все в плюсы, почти все. Blueprint C++ Header Viewer. Это ты имеешь в виду... Header Preview тут есть. Displays a blueprint class in C++ header format. Что это мне дает? Сейчас я загружусь, подожди. ICPP актор, но это который мы на него. И что мне с этой инфой делать? Подожди. Выбери свой blueprint, посмотри. Вот сейчас выбираю BP, Con BP. Вот он, Con CPP, вот он. New var и что? Open selected blueprint in blueprint editor. Не надо мне выбирать. Так. New var, все. Может, я не то выбрал что-то опять? Потому что я их там насоздавал. А, подожди, у нас кто у нас? Parent класс у нас здесь. ConActor. Где наш ConActor? Или что я делаю? Вот оно что. А ну, подожди, вот это интересно. Вот это мы шлепаем. Так, а что? У меня тут дофига всего. U-кластер, перетральвали, U-property. Слушай, это, конечно, здорово, но я, кажется, что-то не понял. Показывает. Так он родителя выбирает. Опа. Опа. Теперь я понял. Подожди, я начинаю понимать. Полезная информация подъехала. Ребята, полезная информация. Сейчас будем обрабатывать ее. Подожди. Надо подумать. Это классная штука. Подожди. То есть он здесь объявил... так это он хедер показывает, да? Получается. То есть он не CPP показывает файл, а хедер именно. И таким образом, если мы сейчас... это вот мы вот этого смотрим. То есть нам бы... Сюда его бы переместить. То есть, если мы здесь сейчас создадим нашу структуру какую-нибудь, USTRUCT, да? Давайте создадим ее здесь еще дополнительно, чтобы мы могли на нее ссылаться. Откроем там какие-нибудь, накидаем разные переменные, integer, я не знаю, float, name, текст, я не знаю, вектор и булевое, все. Сохранить. И на нее ссылаемся, значит, struct. Struct, да? Делаем compile, и что у нас получилось? Где наш struct? Вот он, uProperty. Фига struct, говорит fstruct, struct. То есть это он, получается, сослался на эту, только мы ее не создали. А получается, если мы хотим ее создать, ну, то есть получается, если мы вот здесь вот изменим название, там TTT, допустим, то у нас нифига не поменяется, смотри. Вот, поменялось. Угу. Слушай, ну вот это полезная инфа, вот это спасибо, большое спасибо. То есть, получается можем смотреть, как угу. Можно то же самое сделать с этим, с CPP файлом, то, что выполняется. Вот если сделать то, что выполняется, это все, это все. Это мы сейчас перейдем на такой темп изучения, это просто забей. А можно сделать как-то, чтобы он CPP файл выполнял, то есть нашего актора? То есть вот это вот он все перевел туда. Сам сегодня только узнал. Вот, это прям мощная штука. Еще и копии можно делать, смотри. Я шатал-болтал. Вообще кайф. А можно это сделать как-то с этим? Давайте найдем вот этот вот BP clone BP. Edit blueprint class, create binding class, find content browse. Нет. Блин, мы не можем тогда. Это не то, слушай, ну это прям мощная вещь. Так, SPK. Блин, он видит только хедер. Пожалуйста, разработчики Unreal, услышьте, каким-то образом почувствуйте мои мольбы. Дайте нам простым смертным, вот сюда вот, нет, не сюда. Вот сюда вот таким вот образом. А можно вернуть тебя обратно? Нет, нельзя. Вот такую вот штуку, вот только CPP дайте. Вот CPP и хедер тоже сюда же. Вот, чтобы мы могли открывать и здесь все делать. То есть встроенный IDE-шку свою сделайте. Вот. Что это у нас? Open source код. Понятно. Так. Я теперь хочу найти то же самое для этого. А мы можем, кстати, открыть в теории это, да? А, нет, мы нифига не можем открыть. Если мы нажмем актор, он откроет нам без этих... Ну, короче, вот это вот полезная штука, смотри. То есть мы можем смотреть, как он объявляет эти все штуки, и загуглим, может, плагин есть какой. Ну, сейчас я этим не буду заниматься, я загуглю. Ну, я опять же обещаю потом все сделать, я уже много чего обещал и все забыл. Но я попробую потом сделать, загуглить. По поводу блюпринтов есть не в код, может быть, не по теме будет. Ну, короче, в общем, когда мы копируем вот эту вот всю штуку, то у нас здесь текст на самом деле. То есть, если мы сюда его вставляем, то у нас нифига сюда не вставится. Ну, короче, в общем, он копирует текст. Вот. Кстати, он, если сделать print string и вот сюда вот всандалить, тоже не хочет, смотри. Ну, ладно, короче. Поверим мне на слово, правильно? У меня завис полностью этот, смотри. Меня он delete не хочет делать. У меня, короче, этот завис движок. Да, Unreal завис. В общем, он копирует текст, то есть он есть свой текст, а потом текст обратно в блюпринты переводит. Там есть какой-то сайт, вот он как раз таки этим занимается. То есть он может интерпретировать их, там люди обмениваются своим кодом вот таким вот образом. Вот. Дал супер подробную информацию, да? Вот так что пользуйтесь. Что за сайт, не знаю. Что за этот, тоже не знаю. Так, давайте вернемся к тому, что у нас завис нафиг наш Unreal. Вот это очень полезная история. То есть мы можем подключить... Это подожди. То есть... Если мы хотим, он их, как? Он здесь include не подключает, то есть он нам чисто только view класс определение, но смысл в том, что если мы это сделаем, у нас не будет работать, он его не найдет, USTRUCT, TT вот этот вот. Нам нужно будет header файл подключать, .h вот этот вот. Мощная. Ну да, тут же написано, что это header preview. Вот. А CPP preview нету. Ладно, а будет потом в этом поискать. Может быть, действительно есть какие-нибудь плагины. Вот. Потому что если есть плагины, так это вообще бомба. То есть мы сможем на блюпринтах что-нибудь написать и потом разобраться, что делается в C++. И так вообще так пойдет, то мощно прям пойдет изучение C++. Вот, так, давайте попробуем сделать теперь по гайду нашу структуру в нашем конакторе, который у нас вот здесь, вот он. Здесь у нас есть, значит, наш конактор, да, и вот здесь вот, здесь ее сюда влепить. Чтобы это все сделать, нам нужно ее в хедере объявить. edit defaults only, blueprint read write, USTRUCT, blueprint type, USTRUCT blueprint type, категория. Там есть категория, ну давайте влепим ее. То есть она должна быть за пределами. У нас... То есть она за пределами, она не должна быть не в view классе. Получается, да? А как она может быть не в view классе? Ну да, она у него не в view классе. Ладно, давайте пробовать тестировать. USTRUCT. Struct. Type. Components. Какие components? Actor у нас, да, сейчас идет. Дальше мы, значит, пишем, что это структура. Struct. Вот. И шлепаем сюда generated body. Generated body. Вот. Generated body, public. Public мы прописываем, потому что если мы не пропишем public, он по стандарту будет считать, что это private. Вот, это мы узнали сегодня от этого мужчины, гайд которого мы смотрим. Так, дальше он фигачит обычные, то есть мы дальше фигачим обычные наши переменные, то есть uProperty, property, write нас интересует, то есть чтобы мы могли править его и... Но он пишет read only, то есть чтобы мы читать могли, а мы хотим... Подожди. У него какой-то blueprint read only идет. Да, а потом идет edit and defaults only. То есть это можно только менять в instance, это там, а default это там. И я не помню, где это там. Ну, короче, в одном месте только можно менять. Хорошо, мы напишем по-своему, да, допустим. Edit defaults only. Но у нас blueprint read write идет. Хорошо, мы просто все. Мы ничего больше не хотим. Немного не в тему. Что именно? Так, что именно немного не в тему. Сейчас вопрос какой-то мощный задашь, да? Так, мы пишем float. Float, допустим, ну, тоже создадим там хп, да? Вот. У нас уже ругается он. Я погуглил и нашел видос, где чел показывает методику, как он конвертирует blueprint в C. Глянуть. Напиши название. Да, кидай мне название, я потом гляну. Так. И мы копируем, допустим, еще одну. И зафигачим, точнее две. MP и, я не знаю. Не, еще давайте одну. MP, реген, HP. Давайте сделаем реген, HP, как у нас в том, да. И реген MP. Вот это правильно. MP, так. How to translate blueprint. Так, сейчас я это все копирну. Где копировать? Ага, вот таким вот образом, да? Дедовским стал. Ctrl-C. Куда бы это шлепнуть теперь? А ну-ка, сейчас я попробую супер быстро это сделать. Почти получается, да? Тем- Тут translate, blueprint, C++ guide. Ну, тут их несколько, я их несколько открою. Но именно по такому названию один, а там еще другие есть. Я вон открыл 3 видоса, гляну потом. А так попытка сделать были, но все безуспешны. Это печалька, вот это они должны этим заняться и. Так, а почему он скрыт? Так, хорошо, это мы сделали, это мы закроем, а это мы откроем. Шлеп. Так. Почему сделали это в разы ускорить процесс перехода в плюсы? Да даже не обязательно делать вот это, просто сделайте визуалку внутри самого движка. То есть, как мы вот здесь переключаемся между нашими объектами, между объектами, переключаемся между всякими, то есть вот здесь у нас construction script, здесь мы наш обзор нашего объекта, здесь у нас наши блюпринты, и вот здесь вот сделайте C++. Какой плагин такой есть? Только на 4 Unreal. Ну, все уже. Значит, нету. Значит, нету такого плагина. Вот так вот. Так, давайте вернемся к структуре. Что время идет. Время не бесконечно. Так, мы здесь какую-то фигню наделали. И значит, мы дальше открываем гайд и смотрим, что он дальше делает. Все по гайду, строго по гайду.
To end this thing off. Now, it's going to take a moment here to realize that we actually don't have any errors, and we need to give this struct a name. A struct type needs to start with a F. And from there you can name it whatever you want. So we're going to call this stats. Apparently stats was being problematic, so I just called it character stats. And now we have this character stats struct, which holds a HP value, a shoot speed value, which should be shot speed, but what do you know, a fire rate value, and a movement speed value. And let's go into Blueprint here real quick, and let's say on begin play we want to do something with that. We can make a...
Какого лешего у него все работает, у меня нет. Почему у меня ругается дальше на generated body? Так, USTRUCT blueprint type без категории MB. Может быть, кстати, может быть. Смотри, один в один все. Blueprint type мы назвали. Может быть, из-за вот этих UFUNCTION. Ну, давайте напишем, все по гайду сделаем, все строго по гайду. Read only. Read only и edit defaults only. Ой, что это такое было? Edit defaults only. Вот. И будем вот это вот все сюда переносить. Смотри, мразь. Смотри, какая мразь. Все починилось. Или оно и так сработало и без этого? Короче, давайте компилировать, смотреть, что у нас получилось. Чтобы это сделать, мы вот это шлепаем, а вот это мы компилим. Да. Так. И как у нас там character? Нифига, где наша структура? Где наша структура?
Fire rate value and a movement speed value. And let's go into Blueprint here real quick, and let's say on the gameplay we want to do something with that. We can make a variable of that type now in
ну, дебил, ну бывает. Мы-то скомпилировали, мы создали структуру именно вот такую вот. Но для того, чтобы нам теперь забраться сюда, нам нужно сделать вот как вот здесь вот эта вся история происходит, BP. Con BP, вот. То есть нам нужно также ее подключить. Вот. То есть давайте ее сделаем копию. И вот теперь нам ее нужно вот здесь вот в Protected, вот сюда вот, сделать вот эту вот всю историю. Только вместо USTRUCT, TTT вот этот вот, нам надо F-Character Stats сделать. Вот. Это дело сохранить, это дело закрыть и перезапустить. Да? Или нет? Какое мы ей название дали? Подожди, мы-то тут есть struct, типа просто название, ну там дали точнее. Потому что мы же скопировали, то есть просто struct. И вот наша структура с нашим ХП, МП, реген МП и реген МП. Ура! У нас получилось. То есть, получается, мы можем так создавать структуру и закидывать ее туда. Но мы также и в пустом файле можем это делать. То есть, по принципу, как мы делали, где мы делали это, кто помнит, тот молодец. Вот, по принципу, как мы git делали, то есть пустой наш класс. И здесь мы просто-напросто, ну, git, кстати, тоже структура, смотри. Только там подключали и вызывали функция. В общем, мы через include подключаем его и просто-напросто вот здесь вот таким вот образом говорим, что вот это вот он будет, этот uProperty будет вот он, и вот так вот он будет называться, и все. Вот. Круто, круто. Давайте смотреть, что у нас там дальше. Что у нас дальше по гайду?
Character stats, and if we drag that in, we can split the structure up in, and it has new var.
Ну да, кстати, и это можно было тоже мне сделать. Я что-то затупил. Нашу структуру, вот этот character. Она же здесь только, да, все правильно. Character. Здрасте. Да, вот она. Character stats, то есть, если мы скомпилируем, то вот здесь ее все... Так, где ты? Вот ты. Вот они все будут здесь находиться. Ага, ну, вам видно там. Вот тут вот. Хорошо, ладно, давайте дальше гайд.
Before everything, that's a little stupid, but it has HP and speed and fire rate and movement speed. Now, instead of using a HP float, we can now just use a F-character stats variable as our stats. So let's go look through our base magic character. Somewhere in here we have HP. We're going to change that to being a F-character stats, with the name character stats. That's going to be a little problematic because we're referencing HP a couple of times here. We'll change that in a second. First and foremost, in the constructor, we're going to give these things some default values. So we'll go f character stats dot, and then we can say HP by default will be 50. Otherwise, all these will be by default set to 0. And we, of course, don't want that. So we also want to set our fire rate, our shot speed, and our movement speed. And we're not going to implement most of these things. It's just for the example at this point. So let's say our movement speed would be something like 800 by default. Our shot speed would probably be something a little higher than that, so 1200. Fire rate is, depending on how you implement this could be a number that is number of bullets per second, or this could be the time between bullets. I think time between bullets is easier to program, so let's go by default for 0.75, and then our default HP stat will be 50. Now, anywhere we were previously referencing the HP directly, we need to change that to our character stats dot HP, and it really is as simple as that. So we had our time between fire variable as well. We're going to replace that with our fire rate variable out of our character stats, and then we also want our shot speed. That is a little bit more involved to actually implement because we need to change something about our bullet that we're spawning here after it is spawned, and then we can try doing something about that real quick. So instead of making this an actor pointer, what we'll do is we'll just make this a base bullet pointer right away. And in the projectile movement, which we'll need to include. And if we're lucky, just setting the initial speed to our shot speed variable that we have here will work. But maybe it won't, depending on how things work under the hood. Like, if this is all done within one frame before this thing actually starts moving, this will likely work, but it might still not. And this needs to be in the public section of our bullet here. So let's change the projectile movement component. It would be better to make a getter for this, which is a function that just returns this that is public, while the pointer itself remains private. But for now, this will do fine. It'll work. So with a little bit of luck, that works. Otherwise, it would be a lot more involved and complicated, and I don't feel like going through that right now. So then on begin play, we're also going to set our movement speed with this variable that we have here. So at begin play, we'll get character movement, for which, of course, we also need to add yet another include, because we're going to need to access something from that component, which will be our maximum walk speed, and that we will set to being our character stats movement speed. And now we all have that stuff set through whatever this struct has in its values. So let's make sure that we have this struct as a property that we can add it anywhere. Probably add a default only would be fine here, but it doesn't really matter that much. And now we can see we have in our base magic character, we have our character stats, which we can expand, and it has all of these variables here. And if we go into our enemy, it also should have the character stats, and we want to set the fire rate here to something like 1.
Кое-что сказать по поводу этого, это так мысль на опыте, так сказать, ну блин, короче, ладно, уже прервал, так прервал. Вот, когда делаем статы для персонажа, ну, короче, их надо вносить в таблицу, а потом, когда мы начинаем из таблицы подтягивать и устанавливать в нашем персонаже. И править мы их с таблицы. То есть стандартные такие вот значения. И устанавливаем мы их уже оттуда. Это просто-напросто в дальнейшем облегчит жизнь, так скажем. Вот, когда мы захотим что-то поменять, что-то изменить и так далее. Вот.
0.25 instead. And their movement speed should be a little lower than our own, so let's set that to 700. And then 850 for their shooting speed. They will have 35 HP, where the player might have 100 HP, for instance. And as easily as that, we now have two entirely separate characters. And again, if we were to make a UI, we wouldn't
еще в компоненте
get the shot speed and get the fire rate and get the movement speed. We would just get the character stats. We can break that structure up in, like I showed you before, and you just have access to all that information through one variable. If you need certain values to be always coupled together because they're relevant to each other or whatever, it's generally a good thing to combine them into a struct just to keep your things from getting too cluttered. So now you'll be able to see this is my movement speed, and that is ever so slightly faster than their movement speed. And here we run into a little bit of a bug, and I'm going to keep this in because it's important to keep this in mind. If you're working in C++, it's very easy to just assume that certain pointers are going to have a value, and sometimes they don't. So what's happening here, I think anyway, is in our BT enemy shooting here, we just assume that there's AI controller that works and we have a reference to our base enemy character, and that's fine, and then that enemy will shoot a bullet. But what happens if, for whatever reason, between the minuscule amount of time where this task starts being executed and when we get to this shoot bullet function and everything about that triggers, this enemy is destroyed? And that's what literally just happened. That's why we crashed the game. We were shooting an enemy, it was killed just as it was about to shoot. So at that point, you're trying to access a null pointer, and accessing null pointer will crash your game and the entire editor. So what you want to do is we want to put in just a simple if check for that pointer being valid. And you can just do that like this very easily. And this is where the node results also come in. I know that that's not what this video is about, but we're going to talk about it anyway for a quick second here. Because all we want to do is we want to return success when this has happened. So that succeeded. And then if the enemy, for whatever reason, is not valid anymore, we can return failed instead. And that will tell the AI system that, hey, we tried to execute this node, but it didn't work. So if that for any reason then would have impact on other decisions that have to be made down the line in the behavior tree, that's how you can use that. Again, not what this video is about, but good to know. So now that should be fixed, and I can show you that I walk a little bit faster. It looks like the shot speed thing might indeed not work the way that I might have hoped that it would work. So that's a little too bad. I killed both enemies, and now I can keep going. And I can design more and more levels and add more and more enemies. We can add a enemy type which walks faster. So we can say BP enemy 1 and change this one's material. And maybe we want to make this one slightly smaller. So let's make this one 75% the size, something like that. And then we're going to make him even weaker. So we're going to go down to like 30 HP, but we'll make his fire rate half a second, and his movement speed will be higher than ours. And now we've just designed an entirely separate second enemy, which is fantastic. So we can put that down, those are the materials. We can put like one of these down in the next room and then put an enemy there as well. And now we need to make our way through these first ones. We definitely also need to change up the AI because things were going through the walls there. And these things should also destroy the bullets when they hit the wall, because otherwise we're going to spawn in way too many different bullets that are just flying off into nowhere. But as a general just overview of programming in C++, this is how we set up things and how we can make a game. And it feels like the engine again is crashing. What is the issue this time? Probably a reference to the player, because I think I just died. I think it's this issue here. I was trying to fire a bullet from a player that didn't exist anymore. So again, here we also want to put in a null pointer check real quick.
Да, он ссылается на того, чего уже нет.
If it actually exists.
Движок передает привет.
There's a lot of null pointer things that I probably missed, and that's the thing that I warned you about way back in one of the first videos in this playlist or this series or whatever, is these pointers, they're only real, like, complicated and annoying thing about C++, because this stuff happens. And it can also happen within Blueprint, don't get me wrong, but it happens a lot less. So you're going to need to get used to putting these kind of if statements before a function call like this, just to be sure, because you don't want players finding this out after your game is done. And you don't want to go back over all of your pre-existing code and hoping to God that you just...
Ну ладно, дальше слова напутствия. Там у него еще один видос есть. Вот, 4-минутный How to deal with Unreal Garbage Collection. Я не уверен, что это будет полезно, потому что тут, если брать сегодняшний заход, да, наш, то может быть процентов 10-15 того, что усвоилось, так сказать. Вот, а все остальное пролетело или пролетит мимо. Ну, то есть, пока о нем помнится, оно потом забудется. Но все равно надо. Давайте посмотрим. Еще 4 минуты тут. Значит, идет его How to deal with Unreal Garbage Collection in C++. Вот.
So if you're anything like me and you've been working with C++ in Unreal Engine, you keep telling people C++ is not actually that hard because Unreal Engine provides you with a garbage collector, which kind of nullifies the biggest problem with
Ну, типа, да, не надо следить за тем, чтобы все очищать, он сам это все чистит.
If you've
Тут
been working with it
согласен.
a little bit, you might have run into an issue where it collects stuff that you don't actually want it to garbage collect, like I did with this puzzle. So I've got this little like pipe puzzle here, which still doesn't quite function fully, but every single one of the pieces in here has a concept of being either turned on, like when they're lit up like this, or turned off. They also all have references to their neighboring pieces. So this piece over here has references to this piece, and that piece, and that one, and so on and so forth. Every single one has all of those. I spent way too long debugging why things weren't working and things were generally crashing, without realizing that the reason that I was running into these issues is because those values, all of those values that I just talked about, were being garbage collected by Unreal away from me. So I set them to whatever value they needed to be, and then when I tried to read them, they were either no longer there, or they were, in the case of the bool here, whether or not they were active, they were just being set to false, the default value of 0. So let's take a quick look at the stupidly easy way to solve this. This is just something that you need to be aware of, and once you are aware of it, you'll never make this mistake again. So here we have the header file for those components. Every single one of those pieces is a component in and of themselves, and I've got some stuff like a enum for the directions and stuff, and a struct here that holds the neighboring pieces, which I just talked about. That's all well and good, but this is where we get into the actual important stuff, and that is these things that we have here. These are references to the pieces on every single side. These are the neighboring pieces. And you will note that I marked them all as a U property, but I didn't actually put like an edit anywhere or visible anywhere or anything along those lines in there. And that is because I didn't need that. But I did need to mark it as a U property, because marking something as a U property when it's a member variable of your class prevents Unreal from garbage collecting it as long as the object is still around. So this is quite important to realize. Because marking something as a U property when it's a member variable of your class prevents Unreal from garbage collecting it as long as the object is still around. So this is quite important to realize. If I remove this, Unreal sometimes, quite often actually, we'll just assume that, hey, you're probably not using the value in this variable anymore. I'm just going to garbage collect that because it's taking up memory and you're not actively doing anything with it. So add.
Ну, то есть, получается, не знаю, как garbage collection перевести. Коллекция мусора, блин. Чистильщик, я не знаю, как, короче, Unreal очищает из памяти, получается, эту переменную, потому что если ее как uProperty не объявить, то он воспримет ее, ну, типа, ты ее нигде не используешь, значит, она тебе нафиг не нужна, и все, он ее удалил. Вот.
Just a empty uProperty to that will tell Unreal like, okay, maybe you're not using it right now, but I do need to keep this around because it could potentially be used in the future for as long as this object lives. Now, when you destroy this object, of course, this does just properly get disposed of and garbage collected and all that kind of stuff. So the same thing we did here. This is just a simple bool that sets this piece as being active. So when another piece asks this piece, hey, are you active? It can tell yes or no, I am active or not. That is a value that isn't getting actively used all of the time. So Unreal assumes, hey, you're not going to actually need that. And for like a lot of values here, that is true, because the B is end piece, this only really matters on construction. I need it to be a member variable because I want to set it on a per component basis through just like UI stuff. But the moment the gameplay starts, I don't need to hang on to this value. So it can get garbage collected, I don't care about it. This thing, B is selected. I wanted to make this short video. It's a real short video, I know, because I didn't actually talk about this in the C++ course that I made a while ago.
Я не понял. То есть он ее удалит до момента, как мы ее только не начнем использовать, и потом он ее заново типа создаст?
And I'm not entirely sure why. But I ran into this very issue the other week when making this puzzle, and I figured I never made any videos on this topic, and this seems like something that is important for people to know. So I'm going to append this into the C++ course playlist at the very end as well, so everybody can be aware of this being a thing. And a very big...
Окей. Так. В общем, как я и говорил, 10-15% полезности. Это хорошо. В скобочках не очень, надо было бы больше, но есть что есть. Так, Дальше. Ну, дальше будет дальше. В общем, дальше мы посмотрим на следующий стрим следующего мужчину. Там уже будет на русском, там не надо будет переводить. Никому ничего. Все будет понятно. И вроде как этот мужчина, он как раз таки из блюпринтов. То есть код, выполненный на блюпринте, переделывает в C++. Вот, и вроде бы как объясняет. Посмотрим. В общем, посмотрим, узнаем. Вот, а сегодня мы узнали почти нифига. Вот, надо будет посмотреть Magic Notes. Это у нас этот плагин, да, по-моему. Вот для 4-го Unreal посмотреть. Может, что-то подобное есть. И посмотреть видос по поводу из блюпринта в C++, да, перевод. Окей, хорошо. В общем, неплохо, да. Всем спасибо, кто смотрел. Всем спасибо, кто слушал. И всем пока.